This conference will now be recorded.
Okay. Yes. Hello everyone. So today we'll be starting with the VLSI front end demo training session actually. Okay. So in this session, right, basically it's kind of an introduction on VLSI Guru and also the front end verification course what we have. Okay. So today's session will be mainly focused on front end aspects. Okay. So if any of you are interested in joining the demo session of the backend, right? So VLSI is mainly has two things actually. One is called as front end domain. Second is called as backend domain actually. In the front end domain is what we are currently discussing today. I'll be doing the demo session. For the backend, right? Backend aspects have DFT, physical verification. So these two demo sessions, DFT demo session will be happening today, and physical design will happen tomorrow. Okay. So if anyone is interested in joining that particular demo session to understand how the things go in DFT and PD aspects of the VLSI flow, you can enroll for or you can attend that particular demo session. Okay. You can contact admin of VLSI Guru, so he'll be sending you the demo session links for that. Okay. So myself, Kaushik. Okay, I'm actually working in the industry for past 5 years. So I'm my level of expertise is in front end itself. So I'll be doing the demo session for you guys. Okay. So I also teach here, I teach the advanced aspects of the front end, that is UVM, system Verilog, and protocols actually. Okay. So during the demo session, right, if you have any questions, feel free to ask. Okay. So I will clear your doubts, everything. The flow of the demo session will be initially we'll be discussing regarding what is front end, what all things are covered in VLSI Guru, all those things we'll be discussing. We'll close this demo session by answering your questions actually. You might be having questions, right, regarding some questions you might be having. So I will address all of your questions. Once you are satisfied, we'll end the today's session actually. Okay. Fine. So let's start here. So VLSI front end domain training. Okay, demo sessions. Okay. So the course agenda actually is nothing but we'll be starting off with the course from today onwards. Okay, today starting the demo session. Okay. So we'll be doing the institution overview. VLSI Guru overview will be providing what are the trainings offered by VLSI Guru. All those things we'll be discussing how the placement works in VLSI Guru. Okay. So what is the how do we track the performance of each and individual students, which will help us in giving you the job opportunities. Okay. So all those things we'll be discussing in today. So we will be also understanding regarding electronic systems actually. Okay, that is difference between VLSI and embedded systems. Okay, so in the VLSI design flow, right, we'll be understanding regarding VLSI front end domain flow, and also we'll be just discussing in a brief on VLSI backend domain flow. Okay, just a brief discussion we'll be doing on the backend. Okay, what are the job roles present for the VLSI domain? We'll be discussing regarding skill sets required for each of the courses. Especially, we'll be discussing skill sets for front end in today's session. Okay. So we'll also help you to choose the right domain. Okay. So how do you choose the right domain for you? Either you have to go with the front end verification, or you have to go the back end, either DFT or physical design or layout, like that. Okay. So institution facilities we'll be discussing, how to prepare for the jobs, why career in VLSI is important, or why do you choose career in VLSI. We'll be discussing regarding placements in VLSI Guru, and also ending up with your questions actually. If you have any questions, we'll discuss those questions and we'll end the demo session. Okay. Okay. Fine. Sound is coming very low. Others online students, is my audio clear? Is my audio loud?
Yes, it's clear.
Yes, sir.
Okay. Okay. So Santosh, please try to log off and log in. sometimes what happens is in the online sessions, right, due to some network lag or some you might be facing some audio issues. Once log off and log in back. Okay, exit the session, exit the meeting, and again re-log in. Okay, so it will be clear. Okay, fine. Basically, right, VLSI Guru was founded by Srinivas Reddy. Okay, so he's the founder of VLSI Guru Institute. So he has actually 11 plus years in training experience. He's having teaching basically. Okay, so he has 14 plus years of industry experience. He has worked in big giants. Okay, uh, yeah. So course starting. See, basically, right, coming to the front end verification. Okay, RTL design and functional verification. Many of you have enrolled for front end training for freshers or design verification course or functional verification training for freshers or ASIC verification, right? In for VLSI Guru actually the names. Okay, the names might be different, but all these names they belong to what? RTL design and functional verification itself actually. They're a common aspect. Okay, so functional verification training for experienced engineers. So see, basically what do we do in terms of functional verification? That is, let us discuss what we are offering in terms of functional verification for freshers, or what all these things are there. Front end training for freshers, design verification course, or functional verification training for freshers, or ASIC verification, right? What do we offer from the VLSI Guru Institute in these courses? Let us discuss few points on that. Of front end verification for freshers. Okay, what do we offer actually? Okay, so initially, right, basically we'll be discussing regarding digital design. Your course will start off with what? Digital design concepts. Digital design. See, when I say digital design, right, many of you are BTech graduates, right, recently passed out or pursuing BTech actually. Okay, so you have already come across digital design concepts in your engineering. Yes, sir. Digital design, you might come across it. Yes, sir. In second year or in the first year, second semester, or in the second year, third year, or third semester, fourth semester, you will be coming across it. There, you would have discussed something only on basics actually. What is flip flop? What is latch? Right? How, what is D flip flop? What is JK flip flop? Master slave flip flop? All those things, basics, we will be discussing. K maps, right? Expressions, Boolean expressions, all those things. But we in our institute, we'll be discussing more than that actually. We'll be uh, we'll be doing the basics also. See, we'll be also covering all the basics whatever you have done in terms of your engineering. Plus we'll be making you to get prepared for the interview aspects also in digital design. Okay, so there are a lot of, we'll be discussing regarding like interview point of view questions. Okay, which are part of gate questions also. Okay, see, when digital design, right, questions what they ask, they might be asking just 10 questions only, minimum number of questions they'll ask, but the 10 questions will be in a very tricky level actually. So we are having set of assignments, and our digital design course will cover all the basics of digital. Okay, and it will also, when you do the assignments, right, you will be also getting expertise in how to solve tricky questions in digital electronics. Okay, so initially 2 to 3 weeks we all will be, it might be front end, that is design verification, or it might be back end, physical design or DFT. Everyone, you will be going under one common course such as digital design actually. Okay, so once you complete the digital design, next thing what happens in terms of front end verification is you will be coming across Verilog actually. So in terms of Verilog, right, what we discuss in Verilog concept is we discuss Verilog with respect to design, we discuss Verilog with respect to design as well as verification also. Meaning what? Writing a design test bench, design code, and verifying that design code whether it's working fine or not. Okay, so it's not that directly we'll start off with Verilog actually. It's not that directly we start off with Verilog designing some complex design we take and we do that. We don't do like that. What we do is we teach from the basic actually. Basic means what? From the basic means writing from module to end module. What is a module? What is module name? How to write a module for a particular Verilog code? Okay, from the scratch we'll be teaching you on Verilog actually. Okay, and the tools what we use is model sim. Regarding the model sim installation and how to run the code, all those things it will be taught when during the Verilog training sessions. Okay, so what I'm trying to discuss here is when it comes to Verilog, we discuss Verilog with respect to what? Design plus verification. So in front end, right? See, I told you VLSI is basically has two things actually: front end domain and back end domain. Okay, so in the front end, there is one particular a flow in VLSI called as RTL design actually. For RTL design, Verilog becomes important. Okay, so VLSI Guru also has a course of RTL design as well. Okay, but today we are, I mean, this demo session is for functional verification, front end functional verification. Okay, but in functional verification you are also given a knowledge on how to design a code actually, how to design a code. Okay, suppose you want, let's say you want FIFO, first in first out block, you want first in first out block, you want how to design that, we'll be teaching you in Verilog, and how to verify the design also we'll be teaching you in terms of Verilog. Okay, so as I told you, it's not that directly we go into the advanced concepts of designing. We teach from the basic. Whatever the designs you do in terms of digital electronics, the same designs initially you will be working on in Verilog, writing the code. It might be flip-flops, it might be any of the like half adder, half subtractor, comparator, all those things, combinational block or sequential block. You will be writing that uh, code in Verilog actually, initially on the Verilog sessions, which makes you familiar with the what is Verilog. uh, Online students, is my screen visible? I think some of you are messaging that screen is not visible.
Yes.
Okay,
It's
Sandhya,
black.
please, Sandhya, my screen is visible actually, so please log off and log in again. Okay, I am sharing my screen. Okay, okay, fine. So once you complete with the Verilog, next thing we'll be discussing regarding is system Verilog actually. System Verilog. So again, system Verilog, right? See, system Verilog, it is like it is mainly used for verification purpose. Verification. Its main purpose, system Verilog, the main purpose of its introduction was for verification actually. Okay, what is verification? Tell me. I am saying verification, right? What is verification? So I am giving you my phone. Let's say I want you to verify my phone functionality. I am saying that I am asking one of you to take my phone and verify whether it's working fine or not. What do you do? Basically, you take my phone and you check all the ports first actually. How many ports are there? You check all the ports whether they're functionally working fine. Functionality wise, we are verifying it. Not with respect to structural. VLSI is not, VLSI functional verification is not about structural verification. Structural means not you break it, whether it breaks or not, checking it. Not that. We check the hardware. This is a hardware actually, right? We functional verification checks the hardware with respect to its design behavior. Okay. Now this mobile is its intention is to it has some design behavior actually, right? Phone call, data transfer, Wi-Fi, Bluetooth, right, etc. So those things you verify actually. That is what is meant by verification. Okay, functionality you verify. To verify a hardware through functionally, you have to be having some kind of a language to do that, where you use that particular language, such as system verilog, to write a test bench for it. Okay, so Testbench is like a platform actually, platform built using system verilog or UVM. Okay, so you keep your design upon that platform, you verify it functionally, you verify it. Okay, so system verilog, again you'll be doing one major project here, system verilog. Okay, in system verilog we'll be teaching you from the basics. Okay, so but there is one prerequisite when you come to system verilog. What is that is verilog you should be knowing actually. See, because system verilog is built top of verilog actually. Okay, so if you want to understand system verilog, you should be having 70 to 80% skills on the verilog. Okay, so you have to clear the evaluation, that's what I'm trying to tell, by score of 70 to 80%. Okay, then you'll be moved to system verilog. So in system verilog we teach from the basic, or that is what is in system verilog we come across oops concept. What is data types in system verilog? What is oops concept? How do you write a test bench for system verilog? For any design in system verilog we teach. Okay, so once you complete with system verilog, you'll be next going under UVM training. UVM is not a language, it's a methodology. UVM is called as universal verification methodology. Methodology. This UVM, right, it was introduced into the front end verification 5 to 6 years back. 2017 2018 it was introduced. Okay, so currently all the industry are moving from system verilog style of developing a test bench for a design to UVM. Okay, everyone, all the in the current industry, right, every company is moving from system verilog based test bench verification to UVM based test bench verification. Okay, so why do they move actually? Why do they move from one language to other language? What is the purpose? Features, basically. It provides lot of features which makes the things very easier to implement. Okay, nothing but what are the features they implement is whatever we do in system verilog, right? We should do everything from the scratch. In system verilog, we should do everything from scratch. What is meant by scratch is nothing but I told you that verification is what? Nothing but checking the design functionality, right? So for doing that, what I need, I'll be needing one bench actually, test bench I'll be needing. Upon test bench, I will keep my design. You can take it as IC tester kits. Everyone has come across IC tester kit, right? That IC tester is like a test bench. That IC, what you place on the tester, is like a design actually. So you keep your duty upon the test bench, and you pass the inputs to this actually, and something comes out of this duty, right? You check whether this is whatever things come out, right, whether the things coming out from the duty output, whether they are matching the design functionality. That is what you check. So to doing this in system verilog takes a lot of effort. Everything we have to implement from the scratch. Everything we have to implement from the scratch actually. UVM provides a concept where, or UVM provides methods where these are done internally of the UVM. We just have to use those respective methods to write a code. UVM provides some set of methods which has a logic to send the inputs to this particular test design. Okay, so we will be using that methods to implement the test bench. How we'll do it, what all the methods are present, how test bench is developed, all those things will be covered in terms of UVM training. Okay, so by this time, right, by this time when you complete this UVM course, each and every one of you will be familiar with how to develop any of the test bench for any given design. See, we will be discussing regarding some of the projects. What we have in Verilog is we have SPI as one project, interrupt controller in one as one more project. We are having FIFO, and memory. Some projects we are having for us to get familiarized with the test bench development. Okay, but in your real time, when you once get into a job, right? Once you get into a company, what happens is you might be given some other projects, right? So what is the basic needed? What is the basic needed? Suppose you go to a Google company. Suppose let's say you are hired into Google. Okay, suppose you are hired into Google. Let's say for example. So in Google, let's say you are working on some protocol. Let's say you are working on PCIe. Once you get into job, okay, okay. So you are some that manager will ask you to implement a basic test bench for this particular thing. Okay, so the VLSI means when you come across these courses, right? Digital design, Verilog, basically Verilog, system Verilog, and UVM, you will be getting that much experience that you given any project, it might be PCIe or Ethernet, any project it might be there, you will be having that much knowledge to develop some generic test benches for it. Okay, so to complete the verification, you have to understand PCI protocol. That's it. If you want to complete the verification, we have to learn PCI protocol, which you have to learn. Okay, getting my point? What I'm trying to explain here. So once your UVM is done, we'll be starting with protocols. Once you complete with your UVM, right? We'll be starting with the projects, nothing but. So coming to the project aspects, the first project you'll be coming across is AXI UVC development. Next is Ethernet MAC. Ethernet MAC. So in the AXI UVC development and Ethernet MAC, the common thing what we'll be learning here is nothing but development of the test bench in UVM. Okay. If you want to complete the verification of the particular AXI or Ethernet MAC design, you have to understand the AXI protocol for AXI UVC development. You have to understand the Ethernet MAC design specification for Ethernet MAC verification completion. Okay, so whenever you are coming across, whenever in our front-end verification you come across AXI UVC, it's not that directly we go to the code. Initially we discuss the protocol in detail. Okay, that is what is AXI protocol, where it is used in real time, what are the different features present for AXI protocol. All those things we'll be learning. We'll be implementing that functional check with respect to the UVM test benches, and we'll complete with our AXI UVC development. Ethernet MAC also the same thing. Ethernet MAC, what is Ethernet MAC is something but you know your LAN cables, right? Your laptop has LAN cable. Okay, so one system to other system, LAN through LAN connection, will be using Ethernet protocol actually. Ethernet is one block which will be present in your laptop. One IC will be there in your laptop, Ethernet IC. Okay, that IC takes care of transferring the data from one system to other system. When you using user interface, right? When you say send this movie file to laptop 2 present in the destination IP address. So how that movie files is transferred, that is what we'll be learning in terms of Ethernet MAC protocol. There are companies which are working on the Ethernet IP course. Okay, so if you are very much good into this Ethernet MAC, right? If you are able to complete the verification, understand all the concepts theoretically and practically, so you might apply for that particular job role also. Okay, is it clear? So this is a functional verification course for freshers. Okay, so when it comes to experienced, actually some of you are experienced, I'm guessing, and some of you are joining this demo session might be experienced and you're looking for to learn something in advance. Okay, so when it comes to for experience, right, what VLSI Guru offers is what VLSI Guru offers is we'll be coming across you won't be doing digital actually. For experienced candidates, you will be not going through digital and Verilog. Directly, you will be starting with system Verilog, and you will be discussing something called as UVM main or UVM essentials plus UVM advanced. You will be learning. See, for freshers, you will be undergoing UVM essentials actually. Essentials means what? It covers the basic things required for you to start up your career. Essentials has basic requirements of UVM, which helps you to start up with your career in VLSI Guru. Sorry, not VLSI Guru, in VLSI. Career in VLSI. Okay. So for experienced people, you are already working in a company. You will be looking for front end verification for experience, right? You will be coming across system Verilog. Okay. So you will be coming across UVM essentials plus UVM advanced actually. Okay. So when it comes to UVM essentials, right, the same thing which has basics plus some of the advanced concepts of UVM such as phasing is there, which is a kind of advanced concept in UVM. You will be coming across in experience training. With that, you'll be coming next. You'll be introduced to some projects here. You'll be having set of projects in terms of advanced training, experience training. Okay. So anyone has any questions? Online, offline? Do you have any questions here?
No, sir.
Okay. Class timing. I hope that was already discussed. Means front end verification class timings. Okay. I'll discuss this. What is the class timings? All those things I'll discuss once at the end of the session. I'll discuss actually. Okay. Uh, Functional verification training for experienced. So verification for design and Verilog for design and verification. So there is dedicated. See, some of you are joining VLSI Guru for internship point of view, right? For maybe you are in final year of engineering where you want internship opportunities. So you will be joining to VLSI Guru. So there we are offering Verilog for design and verification and system Verilog for functional verification. There are single courses there. Okay. So that is, you'll be just doing Verilog training with projects, system Verilog training with projects on system Verilog. Okay. So these are mainly focused for internship point of view. Next, you'll be coming across FPGA design and verification. Okay. So FPGA, right? Basically, see, whatever we are going to teach in terms of functional verification, right? Their ASIC flow actually. What is ASIC flow? What is FPGA? I will discuss in today's session going forward. But today we are also starting with something called as FPGA design and verification actually. Okay. So next, RTL design and integration. So I told you RTL design, right? What is RTL design is nothing but you are going to implement a particular design from scratch actually, a real-time design. It might be uh, uh, like, suppose let's say it might be any audio chips, okay, or it might be any process, any audio chips, or it might be any of the communication protocols, SPI or AXI, any new VIPs, or it might be PCI design, which will be coming across. Again, this RTL design itself is a one job role. Okay, RTL design and integration is a job role actually in the front end domain of VLSI, where people will be dealing with designing the complete block, writing the design for complete block. Okay. So what is design? Suppose let's say what is design and what is integration. Suppose let's say for example, right, I'm going to take one SOC based project, SOC block diagram, system on chip. SOC is nothing but system on chip. You take any phone, right? Snapdragon phone, Android phones you take. Generally, there'll be Snapdragon processor. That Snapdragon processor is a complete SOC. Okay, you take laptop. My laptop is a Intel HP laptop. It has Intel processor. Intel is a SOC, system on chip. Now you take any system on chip block diagram. Okay, let's go here through internet itself. Go for images. Let's say for example, okay, take anything. Let's say for example, let us take this particular block diagram. Just take this also. Okay, you take here. This is something called as Leon Spark V8 processor, V8 chip. Actually, this is okay. So what does just by taking a top level view, right? Top level view. Don't go inside. Just take a top level view. What you are able to see? You're able to see different blocks, right? Online students, tell me what are you able to see in this particular diagram? Say I just opened a block diagram of system on chip. What are you able to see
There
in this?
are many blocks and there are a lot of connections.
Correct. There are a lot of blocks present. FIFO block is there, CAN interface is there, HDLC transaction control is there, HDLC receive control is there, right? Okay. So ROM is there, uh, coprocessors are there, right? Many sub blocks are there, and these blocks are connected. Yes or no? These blocks are connected with each other with respect to something called as this line you see here. You see this line, black color line. This is called as bus actually. AMBA bus. AMBA is a generic bus. AMBA has this AMBA bus can be AXI bus or APB bus or AXI, HB bus. AMBA is nothing but advanced microcontroller bus architecture. AMBA is nothing but advanced microcontroller bus architecture. Okay. So this AMBA, right? There are many protocols in AMBA actually. Okay, AXI, let's say for example, SOC, something we came across called as AMBA, AMBA. What is AMBA full form? Advanced microcontroller bus architecture. So this AMBA, right? It has many protocols. Examples are which some of the protocols which you will be coming across in fresher point of view training is APB, AXI, AHB. Okay, you take the Intel processor, or you take Snapdragon processor, or you take M1 chip or M2 chip of Apple. Okay, in that, right, there'll be one of the any there'll be a processor actually. That processor will be a ARM Cortex processor. Yeah, Sagar, please tell me what is your question.
So for front end, are you going to teach all these protocols?
In the front end, right, you will be coming across APB and AXI.
Okay. What
APB
about
and AXI.
what about AHB and AMBA?
AHB, no. See, AMBA is the category. AMBA is a category.
Okay.
Inside AMBA, you are
Okay.
having APB, AXHB, and AXI, etc. A lot of protocols are there. Okay. But in your front end verification training, you will be coming across APB. That is for fresher. You'll be coming across APB and AXI protocols. I told you here projects such as AXI UVC development, right? This is where you will be coming across AXI protocol. We'll be teaching you AXI protocol. Okay. And in the Verilog, right, told you that some projects will be discussing actually. There will be introducing you the APB protocol. Is it clear?
Okay, sir. Okay. So, can you list out
AHB,
which projects you are going to?
yeah,
Hello,
1 minute. Yeah, tell me.
sir. Can you list out
List
which
of
projects you
projects.
are going to take under Verilog?
Correct.
Yes.
I got it. The projects what we are going to teach in Verilog is, first thing is memory. Second is FIFO, both synchronous and asynchronous. This FIFO, right, you'll be seeing in every SOC suite, this FIFO will be present. In almost all the SOCs, FIFO will be present. What is FIFO? It's a first in, first out buffer actually. It's a buffer, kind of a buffer. You send a lot of data. Basically, where you will be requiring FIFO is, suppose you take two blocks which are sending the data in two different data rates. One is sending data in a fast, second is sending data in a slow rate. Okay. So when the first block is trying to send the data in a higher rate, the second block trying to capture the data in a lower rate. Okay. So what happens if there is no buffer is there will be data loss present, or the first processor will be in a bottleneck scenario. To avoid those bottleneck scenario or data loss, we use FIFO in between them. What does FIFO does is it acts like a buffer which works in a first in, first out manner. What is the first data comes into the FIFO, the first data only will go out of the FIFO also. That is the operation. How to implement that? What is the real-time scenario where you will be needing this FIFO? How to write a Verilog code, how to write a test bench, all those things we'll be discussing in terms of this project here. Okay. And we are discussing asynchronous and asynchronous, both as well. Synchronous means what? Both the blocks are in the same speed, same operating speed. That is, the one who produces the data to the FIFO and the one who consumes the data from the FIFO. If I say this is the FIFO, right? If I say this is the FIFO, there will be one block here which will be producing the data and sending it to the FIFO. They're called as producer component. Generally, the technical name what we use is producer component. And there will be one more block here which will be consuming the data from the FIFO. They're called as consumers. Now, these two, producer and consumer, working with the same clock frequency, they're called as synchronous FIFO. Working with different clock frequencies, they're called as asynchronous FIFO. So there are few challenges what we come when we deal with asynchronous FIFO. Okay, those challenges with respect to FIFO we'll be discussing here. How to tackle them, everything. Okay. Next project, what we'll be doing in terms of Verilog is SPI controller. See, SPI itself is a one protocol, serial peripheral interface protocol. Okay, this is this one protocol actually. SPI controller. We will discuss SPI protocol. This protocol, that SPI protocol, is called as they're called as peripheral protocols. Whereas I told you something on AMBA, right? AMBA is called as on-chip protocols actually. AMBA, advanced microcontroller bus architecture, they're called as on-chip protocols. I'll tell you what is on-chip. On the chip means nothing but, I told you that this SOC if you take, right, on the chip is nothing but, this is a chip, right? Inside the chip, block to block communication will happen through AMBA. Like this is one block, this is one block. AMBA protocol will be used. Or from here to, you take here, let's say for example, we use what? AMBA protocol sets. on chip, on the chip. Blocks present inside the chip, communication between them, AMBA, on chip protocol. Say on chip protocol. Okay. Suppose boundary, chip boundary communications. Chip boundary means what? Chip boundary means what? This UART is also, see, example is UART actually. This UART, right, it is used for some debugging port outside the chip present. This is a chip. There's one UART, there's one debug port present here. Yes or no? So this processor will use this debug port using UART protocol. UART is also a peripheral protocol. Okay. Such way, wherever you want boundary communications from the chip, that is inside the chip to outside the chip communications, there we use peripheral protocols. Okay, so out of those peripheral protocols, one of the protocol what you will be discussing in the Verilog projects is nothing but SPI protocol. You will be writing the design plus the test bench for it in Verilog. Next, you'll be coming across interrupt controller. Tell me what is an interrupt? Can anyone tell me what is interrupt? General, forget interrupt controller. Just tell me what is interrupt. Anyone, online, offline?
Disturbing the flow. Continuous flow.
Some interrupt will be sent. At that time it will stop and it will skip and it will go to next.
Yeah, nothing but what we are interrupting a particular execution flow, right? So what does interrupt controller does is, suppose let's say one of the online student raised his hand actually. He interrupted me. See, in online, right? I think Santosh, I guess, he raised his hand. Meaning what? He interrupted me. Yes or no? Or when I'm doing the session, one of the student will ask one question. He is interrupting me, right? Similarly, in real time, right? What happens? There will be a processor present. This processor will be doing some job actually. This processor will be doing some job, some other. So it will be servicing. It will be providing a service for a particular component. Let's say it is component 1. It might be DMA component or any component might be there. Okay, so suppose now what happens is, suppose let's say my SPI, right, it wants SPI controller wants the master's attention. SPI controller wants the processor attention actually. SPI controller has some data in it. Okay, so it wants the processor attention to service its request, service its data. Okay, that is where interrupt controller will come into picture. What does interrupt controller will do is, here I given you one example of SPI, right? But in complex SOCs, right, you will be having multiple such sub blocks present, where all of them will be asking, all of them will be requesting a service for a single processor. Okay, now one single processor cannot go and service every component at the same time. Okay, so then what will happen? There will be a intermediary component present, such as interrupt controller. Interrupt control will be present. So where interrupt controller, you will be processor will be there here, and all the subcomponents, component 1, component 2, whoever wants to raise a interrupt to the processor, this interrupt will go first to this interrupt controller. From this interrupt controller, it will check which of the component is having high priority. Based on that priority value, the service will be given to this. The request of the particular component interrupt will be given to the processor actually. Getting my point? See, what happens is, interrupt controller acts like an intermediary component, where this interrupt controller, based on the component priority values who are raising the interrupt, based on the priority value, that particular component interrupt request will be given to the processor, so that processor can go and service this particular component and clear its operations. So how it performs, what are the real-time scenarios present, design and test bench we'll be discussing in terms of interrupt controller. we'll be discussing APB protocol. APB protocol. We'll be discussing regarding CRC logic. So what is CRC? Cyclic redundancy check. It is one of the data integrity checks done in a high-speed communication protocols. PCIe, Ethernet, right? They have this CRC implemented. Ethernet is also high-speed protocol actually. It is. Okay, what is high-speed protocol? Data transfer happens with respect to gigabytes. 110 gigabytes or 100 gigabytes. 10 gigabytes or 100 gigabytes per second, the data will be transferred. They're called high speed communication protocols. Whenever high speed communication protocols are there we use CRC logic for data integrity check. What is data integrity check? Suppose let's say I am the first person. Okay, I will send one message to him. He will send to the next second person. What I'm trying to tell you is, like, this is the main component. Okay, the main component transmits a particular data to some destination where he'll be receiving the component. So when the data is transmitted from the source to the destination in a very high speed manner, like 100 gigabytes per second or 1000 gigabytes per second rate, what happens is there's chances of data being lost here actually in this medium. Okay, so how do you check in the source and the destination the data are matching? How do you check it? That is where we use error detection, right? That error detection logic, one of the logic is nothing but CRC logic. Okay, that is how you do it. How do you calculate it is what we'll be discussing here. It's a small project. It's like a small project actually. Okay, yeah, so majorly these are the projects what will be taught in terms of Verilog actually. Okay, understood this point. I think Santosh was the one who asked me question. Is it clear? Okay. Yeah, so let's come back to our discussion on AMBA SOC I was discussing, right, where the RTL design and integration comes into picture. So it comes in a concept called as here this particular block diagram. Okay, where you can see that this block diagram has this chip has different blocks actually. Each of this block designing is what we call them as RTL design. Okay, so functional verification is writing test bench for individual blocks is called as functional verification or IP level verification. We call them as. Okay, and you see the connections. You see these connections present. Basically, this is a bus. You see these connections present, right? Connecting all the different sub IPs or sub designs to form a huge component such as IC. The connection is what we call them as integration, RTL integration. Connecting the blocks is what we call them as RTL integration. Okay, so okay, again that is also one of the codes, one of the job roles present in VLSI front end flow. Okay, I was also discussing regarding AMBA protocol regarding APB. This will be part of your part of training for functional verification. AXI also will be a part of functional verification. Okay, so these AMBA architect, AMBA buses, APB, HB, AXI, right? They're used in almost all. They're used in every ARM Cortex processors. ARM processors they're used. Okay, so knowing this will become a very important aspect of your training. VLSI Guru also provides AHP protocol also, but it is not part of your uh, training. It's a different course, which once you complete, I will suggest once you complete functional verification training, once you get the job, then only you enroll for any additional courses. Because mainly our focus should be here what? Understanding the fundamentals of VLSI functional verification through digital Verilog, UVM, system Verilog, and the projects. Once you complete that, get the job, then think of upskilling your knowledge to additional protocols. AHB is one protocol. High speed protocols such as PCIe or DDR, etc. Okay. Uh, Fine. Let's go back. DFT.
Excuse me, sir.
Yeah, please tell me.
Sir, I have a one short question. So, how Verilog languages differ from the Java, C, C++, and Python like software
Got it.
languages?
Got it. I'll answer it. Did you post the question in chat box? I didn't check it. Okay. See, only for RTL design and Verilog, what is the course duration and timing? See, course duration and timing, I will discuss for every course. What is the course duration? What is the timing? All those things I'll discuss going forward. In this PPT, I'm having this respective slides actually. I'll discuss there. But course duration, and don't worry. At the end of this training, you'll be having all the knowledge on course duration and other things. Okay. So your question was basically how Verilog differs from software languages like C, C++, Java, Java, Python, etc. etc. Okay. The first thing is in terms of software languages like C, C++, Java, and all right. Software languages, that is C, C++, Java. What happens is all the codes in this, right? All the codes, all these languages. Tell me, you have come across C, C++, Java, right? Do this language execute in a sequential way or a parallel way, concurrent way? The lines in the code, sequential, right? Whatever you write in C, C++, Java, there is only sequential flow only. There is no concurrent flow present. You can't start two different process execution at the same time. That's what I'm trying to tell you here. Okay, just give me 1 minute. Let me connect my charger. Okay, I will discuss your questions. Just give me some time. I'll discuss this once. Let me answer this question. C, C++, Java, right? There's sequential execution flow. Sequential execution flow. First point. Second point is, can you have a delays in them? Can you delay a statement execution in terms of C, C++, Java software? No, you cannot delay a statement execution. Okay, so delays not possible. Okay, but you take a hardware actually. You take a hardware. Okay, uh, take an hardware. You reset the hardware, right? Means your laptop, right? You click on reset actually. Do you agree? What is the reset doing actually? The reset is turning on your system, turning off your system, give some delay actually, some small delay it will give, where in the small delay no operation will be performed on your laptop. Yes or no? That's what is called a restart, right? When you click on restart, what will happen? In laptop or any hardware will be having something called as restart actually. What will the restart happen? You click on the restart, some background operation will happen, which that operation will lead to what? Shutdown of your system. Some counter will increment, some counter timer will be there where it counts for some particular duration of time. Then it comes back. System again turns on. Yes or no? Right? So that is nothing but about delay in the hardware actually. We are introducing a delay in some process execution. What is process execution? Turn off, delay, turn on. Okay. Now those kind of delays, right, you cannot have in terms of C++, Java languages. The behavior, design behavior, you cannot implement in terms of C++, and Java. That is where we use what? We use example is Verilog. We use example is Verilog. But whatever you do in Verilog can be done in system Verilog also. VHDL as well. I'll tell you what is VHDL. I'll tell you in a minute. Okay. Generally, Verilog, right? Verilog for design is used in ASIC flow. ASIC flow. What is ASIC flow? I'll come across. I'll come to that. Okay. Means you want to design any hardware through Verilog. That is what is called ASIC flow actually. Okay. If you want to design anything through VHDL, we use FPGA flow. We call them as FPGA flow. In FPGA, to design anything, we use VHDL language. In FPGA, right? If you want to design any of the design in FPGA flow, if you want to implement any of the design behavior, it might be a flip flop, mux, half adder, full adder, whatever it might be there. It can also be done in terms of FPGA using VHDL language. VHDL is a standardized IEEE format language. Okay. Verilog is a private companies such as Synopsys, Mentor, and Questa. These people have come together and built Verilog, System Verilog, UVM. Getting my point? Okay. So difference between how Verilog differs. First difference is what? The delay actually, which cannot be there in terms. We cannot introduce a delay between the process execution in terms of C++, Java, whereas in Verilog we can do it. Verilog can have delays. Delays. How, if you ask me how do I write a delay, we write by using hash by the value what delay you want, 10, 20, 30, 40, 1.5, 2.5, like that. Okay, this is the first thing. Next is what? The sequential execution flow. C++ Java, whatever you do in C++ Java, everything executes in a sequential flow only. But whereas Verilog, right, has a concept called as concurrent execution plus sequential execution. Both it has options. Sequential execution as and concurrent execution. Now, if you ask me how to write a code in Verilog for sequential execution, we use fork join concept to achieve concurrent execution nature in Verilog. It might be Verilog, system Verilog, or UVM also. But now just for Verilog I'm discussing. Now don't think that, sir, what is fork join? See, today we are not discussing regarding Verilog actually. You will be learning everything in Verilog, all the constructs in Verilog in the respective chapters. Uh, yeah, is this clear? Again, what is ASIC? What is FPGA? I will discuss. Just give me some time. I'll discuss. Okay. So I hope this is clear. Few of the differences present from Verilog to other software languages. Is this clear? Everyone online, offline?
Yes, sir.
Okay.
Yes.
Uh, the demo sessions basically starts at 9:30. This is all we already come across this. Say DFT demo sessions, right? Today I told you DFT demo session is also going to be conducted today itself. So DFT demo sessions will be on 4:30 p.m. today.
Okay.
DFT demo 4:30 p.m. Okay. If anyone is interested, you can join this demo session. And PD, right, demo will be on Sunday. I'm not sure on the timings. If you want timings, contact the VLSI Guru admins. Okay, but tomorrow it will be there. I was not informed the timings actually. uh, Please contact VLSI Guru for the PD demo timings actually. Okay. So there
Okay.
in DFT, see, I am not the right person to discuss on DFT and PD because I am not expertise in those fields. My expertise is in functional verification. Okay, so for DFT and PD, right, attend those respective demo sessions to understand technical aspects of backend. Okay, so understanding electronic system actually. Something basic we have discussed on SOC, right? So here electronic system, right? So you see, this is the, you take any phone, it will be having what, it will be having something called as flash. You take your phone and you take in your hand, what all component it has, just list down actually. It has, first thing was processor, it has main thing is what, processor. Second thing is what, camera. Third thing is what, mic, microphone, speaker, uh, then what, display, flashlight, like that, etc., etc., right? Many things are present in your phone itself actually. Okay, so what all things make up in the mobile phone? Hardware. First thing, the hardware comes. What is the hardware? Whatever I listed down here, it's a hardware actually. Display unit is a hardware. Whatever you see the display, right, it's a hardware actually. The camera module, whatever you see behind your phone, that's even hardware, right? So chip, processor, screen, USB port, camera, sensors, audios, all those things becomes a hardware point of view. Okay, so there are things which we don't see. What we don't see in terms of my phone, I can't see how my OS operates actually. Operating system, what is my operating system? uh, I think iOS, I think so. And some Android phones will be having what, color OS. Some Oppo phones are having color OS as operating system, like that, etc. Android operating system will be there, and right. So Android and iOS. So something we call them as firmware actually. Firmware are called as drivers. What are drivers? What are drivers are nothing but, you would connect a USB pen drive to your laptop, assume that how the person who is taking care of the USB pen drive data transfer is what is called as drivers actually. So if you notice, right, whenever, so I don't know how many of you have noticed it in your laptop. If you insert any new pen drive, okay, if you're first, it checks for the driver whether it's installed in your laptop or not actually. If the driver is not installed, you cannot do data transfer actually. Okay, uh, what you do, you have to install those specific drivers. It might be USB drivers or PCIe drivers, whatever data communication should happen from the laptop to the external ports. Those respective drivers should be installed in your laptop. If the drivers are not installed, your laptop will not work. I mean, not laptop, the data transfer will not work. That is what is called as firmware actually. Firmware is about drivers present. Drivers are responsible for data communication between your laptop to the external port. Example is USB port. You will be requiring USB drivers. Okay. OS. example I told you, right? iPhone has iOS, Android has Android OS. Many Android OS are there currently in market. Applications are what? The applications what you run in your laptop or mobile. Applications such as what? Message application, WhatsApp application, Facebook, right? The MX players, etc. All those are applications. Those are things which we don't see. I can't see my driver present in my phone or in my laptop. Even if you open the laptop, you can't see the driver actually. What do I may open the laptop? You break the laptop, you open the laptop, you see the motherboard, everything, but you can't see the drivers, you can't see the OS, you can't see the applications present. Those are things which cannot be seen actually. They are software related. All these are what? Software actually. Okay, there will be application engineer who will be responsible for developing the apps, or app developers. Software, right? There's a job called as app development. Okay, so these are belongs to the software point of view. But hardware is what? Chip, processor, screen. So if you want to, the VLSI flow comes in the hardware development of the particular product. But what is a product? It's a combination of both hardware plus the software. That's what we say. What we see is a hardware, what we don't see becomes a software there. Okay. Again, same. Mobile phone has 4 layers: hardware layer, firmware layer, operating system layer, application layer. Hardware layer is where we are having processor, camera, sensor. Who develops hardware? VLSI engineers. Okay. 1 minute. I will come back to your question, Soumya. Okay. Let me complete this slide. So what I'm discussing here is hardware has processor, camera, sensors. Who develops this hardware? VLSI engineers. Again, when it comes to VLSI engineer, one engineer is not responsible for doing all these things actually. There will be a whole team. Okay, let's say you take for example Google. Google has how many products? It has live software. Google has how many products? It has wearable products. The watches are there, right? Wearable smart watches. Phones are having, means
Smartphones.
from past 4 years they have come across phones where they work on tensor processor. What else they're having hardwares? Just list down whatever you come across, just list down. I have written two. Anything else is there? Speaker is there? Okay, speaker. I'm not sure. It is there? Google Assistant. Okay, fine. Like Amazon, right? Okay. So these are the products present, example products present of a company called as Google. Okay. Now for this particular, let's say smartphone example, let's take, there is one team for smartphone development only. Okay. Those team will be basically, let's say 100 people team it is. Assume it's a 100 people team. Doesn't mean that all the 100 people are working in the one development, one particular hardware development. No, it is spread through the entire VLSI flow. RTL designing. First, see, the first VLSI design, means front end design, starts with what? VLSI front end. Front end starts with uh, what is marketing actually, nothing but requirements, gathering the requirements. This is nothing but a marketing team who does this. What all things are required for this particular phone, which is going to come out in 2024 or 2025? What are things are needed? Those things they gather up first. Second thing is for architecture comes. Architect. Okay. Third thing is what? RTL design comes. Design integration also comes. RTL design and integration. Fourth point comes is what? Functional verification. This is where we come. This is the part where we come actually. Okay. Functional verification. Okay. So So this is the place where we are coming into picture. So in this function verification is what we discuss on. We are doing our codes on Verilog, system Verilog, UVM. Now, what is the difference between Verilog, system Verilog, and UVM? What is the difference? Difference between Verilog, SV, and UVM. See, I will tell you difference is, see Verilog, right? Verilog has only handful number of concepts. I'll tell you, Verilog has 30 concepts maximum, 30 to 50 concepts only. 50 concepts means what the data types are how data types actually nothing but 30 to 50 concepts are present. Okay, using which we develop, design, and test bench. Design and test bench. So when we come to test bench, right? Test bench. See, test bench. I'm saying right. Test bench itself does many operations actually. What are those many operations? Are first thing is what? It comes under input generation. In the test bench side, I have to apply the stimulus for my design. Stimulus is my inputs to the design I have to apply. Okay. Second is what? Capture the outputs. Whatever the design inputs I'm going to apply, design will give me respect to outputs also. Okay. So I have to write a logic to capture these outputs from the design. Okay. Capture the duty outputs. Second thing, what happens is uh, compare these duty outputs with respect to compare this duty outputs with respect to design behavior. Design expected behavior. So if I give you one small example for this, right? If I give you one small example for this, uh, you are all familiar with multiplexer, 2x1 multiplexer. Okay, small example is nothing but mux 2x1. Okay, so multiplexer, right, chooses its inputs based on the selection lines what we provide. Okay, so if select line is generally, if you take this is a multiplexer 2x1, we'll be having one select line, we'll be having one output, we'll be having two inputs, let's say I0 and I1. So if select line is 0, if select line is 0, output is what? I0. Whatever I pass in is I0. It might be 1 bit, 2 bits, 3 bits, whatever, how many ever bits information I provide in this I0, that information should be coming in the output actually when select line becomes 0. That is one functionality of the mux. Okay, now anything can go wrong inside this, right? See, it might so happen that this 2x1 design people who have implemented that might be wrong actually. Okay, so before even this mux goes into the actual IC, right, we have to test this mux. So that testing is what we do in terms of test bench, where I generate the inputs actually. What inputs? Select inputs, I0 inputs, I1 inputs I generate. I capture the outputs in my test bench, and I compare this output with what is expected from the design. If the expectation is not matching, design has a fault. We have to rectify that fault. Okay. Now for doing all these things, right, Verilog provides very less concepts. Okay, which makes it suitable for only for designing. Okay, for test bench point of view, it is difficult to implement. That's what I'm telling you. As the project keeps on, complexity keeps on increasing, all the things of test bench cannot be done just by using Verilog, because test bench has a lot of things to implement. Okay, so that is where we go with system Verilog actually. That is where we go with SV concept, system Verilog. System Verilog, where system Verilog purely based on OOPS concepts. OOPS, object oriented programming language, which achieves reusability of the code, reusing of the code, and modularity. Okay, so system verilog becomes what? See, OOPS concept, right? Whenever you use OOPS concept, it's a class actually. We develop the concept using class we do. And OOPS concept is all about class, polymorphism, inheritance, encapsulation, data hiding concept, and all also on. Data hiding means what? Declared a variable, you're providing a kind of protection to the particular variable. Who is accessible, who cannot access it. I might see some of you, it might be very difficult to grasp it because I'm saying something called OOPS and all, right? Some of you might not come across C++ language to know about what is OOPS. See, what I'm saying is you don't want to worry much. Even when you go for system verilog, right? It's not that we don't teach you OOPS. We will teach you OOPS from the basic. Some of you wouldn't have come across C++, Java, right? Because you're all maybe all of you are electronics background. I don't think so you'll be coming across C++, Java courses in your engineering. So it's a natural that you will not be coming across OOPS concept. But in system verilog, you don't need to worry about that things. We will be teaching you everything from the basic. See here, the main focus here is what is the difference between Verilog, system Verilog, and UVM. Okay, Verilog, right? Testbenches has lot of things to implement. So Verilog language provided concepts are not sufficient to implement all of these things effectively. Okay, so we are going to system Verilog, where system Verilog provides OOPS concept, which helps in developing these test bench requirements in an easy manner, easy approach. For now, in a summary, briefly, I can say only this much. Okay, makes test bench development easier. Next thing is what we are having UVM actually. What is UVM? UVM is not a language. First thing understand is UVM is not a language actually. UVM is a methodology. Methodology. Methods means what? Methods which are implemented using some language actually. Yes or no? So UVM is implemented using SV language itself. UVM is it's like Python has methods, right? It has some methods called as add method, right? So how that add method is implemented? It will be implemented using some language. Which language? C++ languages. In terms of UVM, UVM is a methodology. It has methods only. Some methods it has. Those methods are implemented
Like
using system verilog language itself. Okay. So why are we introducing UVM? Why UVM is required? See, system verilog, right, has lot of common things present in all the test benches. SV has lot of common things in test bench development. What are those common things? Input generation is the same actually. Okay, only what number of inputs we generate will be different. It might be 2 inputs for a particular design or 10 inputs for a particular design. So input generation logic are they're common. So all those common things what is present, they're kept in terms of UVM methodology here. Getting my point? Okay. See, system. If I system, see, the thing is to implement Verilog, right? Verilog test bench for SOC will take 6 months. If I give a number, it might take 6 months to develop. Because of less concept present, everything need to be implemented manually. That is what it is. Means the checking what we do here, they are done manually. System Verilog test benches for SOC will take, let's say, 4 months because of reusability present and the checking, right? Even for checking the design behavior also, system will provide something called as assertions and coverage, okay, which Verilog has no such concept, using which check the time consumed by the system test benches development will be 4 months only. Whereas when I take UVM, right, UVM, what it does, common things UVM will provide inbuilt actually. You don't need to develop from the scratch as of system Verilog. So what does UVM test benches for SOC will take hardly 2 months. Okay, because UVM provides every methods for system Verilog. Whatever system Verilog takes hard coded implementation, UVM will provide uh, those methods actually. See, today's session I won't be able to tell you much detail also, because if I take one example, it might take you are not in that particular level to understand that particular things, because you have to go through the basics first. Getting my point? So I am just trying to give you a top level overview in difference between Verilog, system Verilog and UVM. Understood my point? You might think, how is he saying like this and all? Okay, if I try to take one small test bench, right, it will take a lot of time, and to be frank, those particular test benches you will not be able to grasp also. Okay, because you have to go through the basics first in order to understand test bench and all. Okay, even the concept of test bench which will be introducing in Verilog project level only. Okay, we won't discuss anything before. Okay, I hope now it is clear on what difference between uh, Verilog, system Verilog and UVM. Okay, it's a library. UVM is like a library. So if I show you, right, I have that library. It's an open source. UVM is an open source library. Even you can download and you can build your own company for test bench development. Only thing is, in financial should be there. You can open anything, like let's say UVM, right? You go to UVM source code. This UVM 1.2 is what is the recent source code provided by the Accelera people. Open this. SRC is there here. It's nothing but a library actually. Okay, nothing but a package. In the package, if you open this package, it will be having see, it's a license basically. So these packages will be having all of these things: DPIs, base class, TLM ports, components, all these things, which will be used for UVM test benches. Okay, fine. Let me answer your questions. Santosh, you are saying that can we say test bench is similar to test cases? Answer is you can't say both are similar. Test bench will use the test cases. Okay. See here, if anyone has anything apart from the, if any of your offline students are having anything apart from the session to discuss, you can go out, discuss, and you can come. I see some of you are discussing and laughing and all. If you have anything to be discussed, you can go out. I'm not going to stop you guys. You can go out, discuss, and you can come back. Getting my point? See, you sit here, I sit there, and I laugh. It won't be good actually. The entire concentration will go there only. Correct, right? And that will disturb not only you both, it also disturb the remaining people who are attending offline and also online also. Okay, see, that's what I'm saying. See, I'm very open. If you want to discuss something, have any phone call present, you can go out, speak, and come back. I'm not going to stop you guys. Okay, you don't need to ask permission also. You can go out, speak, come back. Not a problem. any phone call, anything important is there. Okay, but in the class please do not speak. Okay. Okay, so we say test bench is similar to test cases. See, the to be frank, right? They both are not same. Okay, they both are not same. Test bench is like a structure present. It's like a verification structure present. Test bench is like verification structure for verifying the design functionally. Functionally, functional aspect of the point, the design is working correct or not. We check that structure. It has subcomponents. This test bench structure has some as few subcomponents. Subcomponents. We call the first component here as generator. This is the name what you give it, generator. Where this generator will develop or will generate that the inputs to the design based on test case, what your test cases. Okay. Now what is test cases, you might ask me. You take a SOC. What is test case? What is test case? You take a SOC project, SOC block diagram. Let's take A15 Bionic, I think so, right? Recent one, A15 Bionic processor. Okay. Now this particular processor, it has what? Basically, what does it has is, it has it's used for uh, it's used for processor. It's used as a processor for smartphones, right? What smartphones, you know what smartphones are used for. Now what do they do? What do they do? Basically your processor will be having some subblocks also. This A15 Bionic, right, it has some subblocks as well. That is display operation. Whatever the inputs you type on your display, right? You type something, you do the touch operations, right, on your display. Who is going to process that particular operations? Your processor only will do that. Okay. So one of the test case, one test case will be what? Display test cases. It can be there. Where display test cases will apply some random inputs which are specific for your display module. Understood. Next is what? It might be your memory, your RAM or ROM, right? Your RAM storage related test cases. Nothing but what you have to do, some writes and reads to the RAM. Your processor has to do writes and reads to the RAM actually. And there will be some camera, right? Camera unit will be there, or retina scanner, right? Retina scanner is there, no? Which is meant for security point of view. Okay, so even for the retina scanner also, whatever that front camera is there, no, the front camera of the iPhone is used for scanning your face. Something operation is there. I'm not that much sure on what it does, but basically the eye scanning feature what is there in your smartphone, iPhone, for what? For security purposes, face unlock, face authentication. Okay. Now what it does actually, even for the retina, it's sensor actually. It's something about a sensor. There'll be one IR sensor present which projects some light for IR light for your face, and it captures back. Okay. Now how that pattern is there, when each face patterns are different actually, right? Some difference will be there. So how that all those things work? Basically, this bionic processor will be coded with some predefined pattern actually, to where from the retina scanner, if this particular pattern is coming, then this smartphone should get unlocked. That is one feature actually. So that feature also we are scanning with respect to retina scanner test cases. Example, I'm just saying. Such way we'll be having different test cases which are going to target specific functionality of the design. Getting my point? What is test cases? What is test bench? Test bench is a structure which has one subcomponent called a generator component, which will be generating the design scenarios for specific, uh, which will be generating the inputs for the design based on specific scenarios only. Understood this point? Such way it has many blocks such as drivers or BFM we call them as. Okay, BFM it's mainly used to connect the test bench environment with the duty design. We use it. For now I'll just list down the components. I won't go much in detail. BFM we are having, monitor we are having, scoreboard we are having, uh, coverage we are having, assertions. These are the different components, major components of your test bench. Each of them are responsible for doing some operations. As I told you, generator is for generating the inputs. BFM is for what? Sending the inputs from the test bench, from test bench to duty. Nothing but design. Monitor is what? Capture. I told you, right? Once you pass an input to the design will give some outputs. Test bench has to capture that output. So that is where we use monitor actually. We capture design outputs here. Scoreboard, we do what? Data integrity checks we do. Data integrity means what? Memory. Basically it comes into point of memory actually. Okay, whatever the test bench is doing the memory write, when memory is being read, see, you are writing something to the design memory. That's the write operation. During the read back, right? The design output is where we'll be reading the data from the memory. Okay, now I have to compare this data memory data output and the memory data input. That comparison is where we do in terms of scoreboard. That is what we call them as data integrity checks. We do. Now next we come across coverage actually. Coverage is coverage. What does coverage? There are two types of coverage here. One is called as functional coverage. Second is called as code coverage. So what is functional coverage? What is functional coverage? Else if all the design functionality is covered from test bench point of view. From the test bench point of view, right, are we targeting all the functionalities of the design? That is what we are going to get in terms of functional coverage. Code coverage is what? Design functional point of view. Design code. See, your test bench will be generating different test cases, right? So in the design right, in design, if we have 100 lines, all these 100 lines are meant for some purpose only actually. We don't keep some dummy lines there. Some non-use cases lines we don't keep. In the design, each line is important. It does some operation, flip-flop operation or storage operation, something it does actually. Okay, so all 100 lines are meant for some or the other operation of design. Okay, so code coverage will tell us all if these lines are covered or not. Code coverage will tell if all these lines are covered or not. Getting my point? these things coverage the scoreboard, basically coverage assertions, right? This cannot be done in terms of Verilog and all. Okay. Assertions is what? Assertion is nothing but any timing checks are required. Any timing checks in design are done, are any timing checks are done in design are checked in assertion block assertions. Okay, like timings means what? One signal might be high in one clock cycle. From the duty, the acknowledgement from the duty will come across at some different clock cycle. Those kind of timing checks we want to implement, we use assertions here. Okay, just in a brief I am discussing, because this itself is a some separate chapter actually to be discussed in system Verilog and UVM, which where we'll be spending around 1 week time to do understand all these things. Okay, uh, let's go forward. uh, so in company we don't use Verilog because it's a time consuming activity, right? As we see in company, right? In company, we use Verilog for duty design. SV, majorly I'll say major companies will use UVM for test bench. I won't say system Verilog because nowadays everyone are going to UVM only. So majorly companies will use UVM for test bench. Okay, Verilog is not used for test bench. Time consuming is the first thing. Second thing is it doesn't provide that much features for test bench effective implementation. Okay. On a high level, can you please share what test bench means? Gayatri, this will answer your question actually. Whatever I told you here, right? These are the test bench components. It's a structure actually. Okay. Next is, it means UVM has predefined test. See, UVM has not predefined test benches. It has few predefined methods to implement the test benches. Okay. Uh, Offline, you are having any questions? Offline, anyone has any questions? Yeah, please tell me. Online also, if you are having any questions, you can unmute and you can speak, or you can post in chat box. After this, right, we'll take a break actually. After this, we'll take a break. After the break, we'll again continue. Okay, I'll just complete off with the remaining aspects. Yes, Soumya, you had some question. Okay, no questions. Okay, fine. Take a break for 15 minutes. We'll come back on 11:30. Okay. Okay, some question is there. 1 second. Along with the course, what are the other things we have to learn? See, if you are asking me with respect to interview point of view, with the course, what are other things you have to learn is, from my experience, what I'll say is, learn how to, wait, I'll tell you. See, what I see when I take interview in my company is, I see few people struggling with language actually. Communication is what I'm saying. First thing is for communication. If anyone is not good in communication, English, I think VLSI Guru also has some extracurricular activities actually. I want you guys to participate in that. That is it's a part of the course, but we don't highlight it. But it is done as an extracurricular activity. Okay, what is that is like, we are aptitude test and all we are having already. We'll be having some kind of presentation sessions. Okay, so I want everyone to participate that. See, presentation, right? It has two advantages. One thing is, you're coming here and you're speaking, coming on the stage and you're speaking, which will remove your stage frightening that will be there, right? Which will remove that. Okay, second thing is, conceptually also you'll understand, because the presentation will be related to your theory sessions only, or a particular module, Verilog, digital, or whatever it might be there. Okay, third thing is, communication will increase. Like when you speak, right, first presentation it might not go well, second also it might not go well, third it will definitely be better compared to the first two. So what I would like you to learn is communication. The technical aspect you're already learning, technical aspect you're learning here. Okay, additional thing is what? Communication, aptitude. Aptitude, VLSI Guru will be connecting monthly 2 or 3 times every weekend, Saturdays, monthly twice. We'll be conducting one aptitude test. Okay, please join the test to know where you are standing in the aptitude. Okay, and you should also some learn, like you're having 6 months time from today. Every month, take one particular aptitude question, aptitude topic, and practice on that. Okay. These are two things what I will say, communication and aptitude is the only thing apart from technical what you have to learn. Remaining things we'll be doing it in our training itself. Okay, no prerequisites, I'll tell you, no prerequisites. Only thing is what, if you want to uh, you should be having that interest, that is a prerequisite, I'll tell you. If someone is joining with forcefully, right, it might not support you. You should be having interest to do. There is no prerequisite. Digital also, I'm telling you, right, in BTech, if you are not done digital, don't worry, we will teach you how to do the basics of digital also. Getting my point? We will mold you in such a way. Okay, there is no prerequisite for this one. Only prerequisite what, you should be having interest for learning VLSI. That is the only prerequisite. Okay, that is the only thing what is there.
What about mock interviews?
Yeah, mock interviews. What about mock interviews? Mock interview, see what happens is, once you complete the uh, training, right, 6 months of training, uh, once UVM is completed and the project is completed, in terms of functional verification, you will be added into the job support groups. There'll be a separate group called a job support group, where in the job support group we'll be posting all the uh, job requirements coming to VLSI Guru. Okay, so you have to send, we'll be sending one form actually, one form to fill, we'll be sending that form. You have to fill with your resume, updated resume. Okay, what we will do is, we will first do mock interview of you, of a candidate, before we pushing you to the to the company actually. In that mock interview, when we ask questions, we'll also explain you how to answer that question also. First we'll give you the chance to answer the question. If you're not able to answer it, or if the answer is not met up to the mark, we will teach you how to answer the particular question. Getting my point? What is needed to be answered, what is not required to be told, like that. That is how we take mock interviews. It will be done once after you complete your UVM. But what we do is, what is our what we do, what we are implemented from previous batches. After every module, after Verilog, there will be one mock interview for everyone who's attending Verilog actually. After each module, we are going to keep a mock interview. This is what we are implementing from previous batches, one batch back. Okay. So mock interviews will be conducted after each major after each modules. Okay, so this after Verilog, one mock interview will be there. After system Verilog, mock interview focused on complete system Verilog. After UVM, mock interview focused on complete UVM. Okay, then one main mock interview will be there once you are going for the interview. Before interview, main mock interview will be present also. Okay, what is the concept of a mock interview is we teach you how to answer. You should first, we'll give you a chance to answer. If you're not able to answer, or if your answer is having some unwanted things and all, we'll tell you not to say those things. Keep very much specific to the question what they're asking. We'll mold you actually to say those answers as well. Each company, like let's say Wipro, before going to Wipro, we'll be having one mock interview. Let's say we got one requirement for Smart Sock. Before Smart Sock, we'll be having one mock interview like that. And see, the thing is, here is where students will fail actually. First thing is, students will not attend mock interview. If you're not attending it, you can't say, see, if you're not able to attend the mock interview, if you're not able to answer the questions in mock interview, you cannot expect to get job in interview. That is the main thing actually. So take mock interviews very seriously. Even if you're not prepared, also attend it. You will know where you're standing. That is the main thing of mock interview actually. What is the main thing of mock interview is know how to say the answers, know where you're standing in your concept. Okay, based on that, you have to learn, study hard. Support you require, you can ask for trainers, they'll provide you actually. Okay, I think let's take a break. Okay, because it's already 11:20. Let's take a break for 15 minutes. We will meet up at 11:35. Okay, 11:35 we will meet. Okay, you can take break. Thank you.
This conference will now be recorded.
Yes, hello everyone. Online students, am I audible?
Yes, sir.
Okay, let's continue. Okay. So electronic system, one analogy they're giving us, where buses with passengers. So buses are like hardware, driver is like a firmware in the bus, conductor is like operating system, passengers are like what, applications. Okay, so use cases, a passenger wants bus to stop, intimate to the conductor actually. Conductor informs the driver will control the bus to stop. Okay, so basically nothing but uh, if at all a hardware wants to stop its execution, okay, hardware cannot just stop its execution as it is. Okay, it has to first inform to the driver that I am going to stop the information. So it has to first inform to the operating system, saying that operating system that I have to stop I have to stop my execution at this particular point and wait for some other instruction to happen. So hardware will communicate with the operating system. That's what we are trying to say here. Hardware will communicate with my operating system, where operating system will in turn communicate with the drivers. Okay. So example is what, when USB device is connected to your laptop, what happens? USB device gets detected. Your laptop, right? Once you connect a pen drive, that pen drive option comes up in your PC, this PC, right, where it shows all your connected devices present. Okay, so we start doing transfer to USB devices. So USB driver, what a driver is nothing but it will be having some set of assembly level instructions, where see directly nowadays, right, directly we don't write assembly level code, we write assembly level code using embedded C. Generally it's a embedded C code. Okay, where there will be a tool which is going to convert which is going to convert the embedded C to assembly level. Embedded C to assembly level conversion will happen. So you write the driver code using some C languages. Okay, those C languages will be in turn converted into assembly level instructions for the drivers. So does bus driver manufacture the bus? Does the bus driver manufacture the bus? No, right? Bus driver is not responsible for manufacturing the bus actually. Okay, it is some company who is responsible for manufacturing a bus, Tata company, for example. Similarly, UVM USB driver, right? It's not what is it? It's not the hardware that manufactures the USB driver code. Some companies will be there, generic companies will be there, which will be manufacturing the driver codes. Okay. So same way embedded in system engineers is only responsible for developing of drivers. Hardware engineers are not responsible for developing the drivers. Hardware engineers means what? Like us, functional verification engineer. I am not responsible for writing the driver code. For me, the embedded engineer will give me the driver code. I have to just use the driver code to perform the operations. That's it. What operation? USB operation, data transfer operations. Getting my point? Uh, so current mobile screen turn off time is 30 seconds. We want to change that power of, I mean, display turn off time will be there, right? Screen saver, something you call them as, right? So you want to change the time value from 30 seconds to 60 seconds. That is one of the example what they're using for driver, to understand driver examples. So how do we do it? Do we open mobile, apply the number 60 on hardware? Do we do that? Do I break my mobile, I open that processor and write 60 upon that processor and close the hardware? No, right? We don't do that. We use operating system to do it. Okay, what we do? We are using some applications basically, right? You shouldn't directly interface with the hardware. Your application will interface with the hardware. So how do we do? Open the settings. We search for the particular screensaver application. We change it from 30 to 60. So this instruction goes to OS actually. Okay, whatever in the application we did the command, it will go to OS. Okay, OS conveys this to the power management related drivers. So these drivers consist of instructions for processor writing to a register in the design to change numbers 30 to 60. Okay, your design will be having some registers, whether changing the particular register value from 30 to 60. That's it. Okay. So as a VLSI engineer, right, you need to understand how the hardware works. See, this is a very main thing when you come to job. Okay, when you come to a job, right, uh, whatever you learn, system Verilog, UVM, it will be common for every project. That is the basic what we are teaching you. Okay, with that some projects we are teaching such as Ethernet MAC and AXI. But the main thing what comes is when you go to a particular job, client or a product based, whatever it might be there, that company will be working on some project actually. As I told you, Google, one example I told you that they are working on smartphone. Next is some tensor processor they're working on. You have to, once you get into a job, right, get into the company, you have to understand how that processor works, how their processor works actually, how Google tensor processor works. Getting my point? That you won't find anywhere else, that you won't find any institute also actually. How Google tensor processor works, you will not find in any institute also, because it is proprietary to Google itself. Example I'm saying, or Qualcomm, or any other projects. So your main responsibility will be what? First understand how the things work there, how the project works. then implement that logics using system Verilog, Verilog and UVM. That is should be your main thing. Okay, the theoretical whatever you learn here, you will be implementing this by understanding their projects. Okay, for example, you are put into PCI project, let's say for example. Now you wouldn't have come across PCI. You don't know what is PCI. What you should do? You should first study PCI protocol. Then only you can do something on that. You don't know what is a subject, you cannot implement practically. Okay, so you as a VLSI engineer, we have to upskill ourselves every year actually. Every year we have to be learning new things. So as a VLSI engineer, you need to understand how a hardware works. In-depth understanding on hardware developing steps, how firmware interface with the hardware, decent understanding on how firmware works with the hardware. Means regarding drivers and all, right? You don't need to go in that much in depth. Just basic level, how data is communicating, that means sufficient, because that's not your job actually. Writing driver code is not your job, but writing the functionality of a particular design is your job. So you have to understand the design functionality in depth. Okay, the interfaces, the driver interface, you don't need to understand much. Okay, and don't need to worry about operating system applications and all, right? We are not responsible for any OS development, operating system development, and we are not responsible for it. So you don't need to think of that itself. Also only you have to understand what the design, what you're working on, understand the design very detailed. How will you understand it? By reading the documents. The company will provide you the documents, you have to read it first. And in our projects also we will do the same thing. Ethernet MAC project is there, right? We will read the document first, okay, in our course. Then only we'll implement the functional code for it. VLSI design styles. Basically VLSI is very large scale integration. Okay, what are we integrating? Transistors. Since we are integrating billions of transistors, it is called as very large scale integration. Okay, I'll just quickly go through this PPTs. So two major styles are there. See VLSI, right? There are two major styles, ASIC and FPGA. So earlier you had a question regarding what is ASIC, what is FPGA and all, right? Today, now I'll discuss that. So the two major styles are ASIC flow and FPGA flow. What is ASIC flow? Application specific integrated ICs or integration circuits. Okay, so hardware is developed for specific applications only. You take a laptop as a processor, Intel processor, that is a ASIC processor actually. It is specific for laptop only. You can't take and keep it in mobile and you can't operate mobile. Or you can't take the laptop processor, keep it in washing machine and you can't operate washing machine. Not possible. Getting my point? Chip developed for specific purpose. They are called as application specific integrated circuits. That is where we use Verilog, system Verilog, UVM. Okay. Example is they are given example as mobile phone chip. So you can't go and take mobile phone chip. Mobile phone chip will operate only for mobile only. Okay, and that to specific hardware mobile, like some model of the mobile. You can't go and keep this mobile processor into a washing machine and say washing machine to operate. It won't happen. It won't work. Okay. FPGA is what? Field programming gate array. FPGA is called field programming gate array. What is field programming gate array? Is there will be a board present actually. A generic board will be present. Okay. Same FPGA board can be programmed to behave like different applications. Okay. Same board is there. It can be programmed to handle different types of applications or different types of electronic devices also. It can behave as a mobile phone. Same board can be programmed to behave as a laptop chip also. Okay, but what is the drawback here is, I'll tell you what is drawback, I'll tell you. So which one looks better? Though it looks like, see, just by the definitions, right, you can say that FPGA looks better actually, because one chip, one board can be done many things actually. You can say that FPGA is better, but Though it looks like FPGA approach is better, however, industry preferred is ASIC design flow due to low cost of manufacturing. ASIC chips, right? Laptop processor, they are low cost in manufacturing actually. Okay. So if ASIC is cheaper option, why we don't do everything in ASIC? For ASIC, initial investment is high. See, for if you want to, if suppose I want to develop my own company for chip manufacturing, initially I have to invest a lot of things, lot of money I have to invest for manpower, nothing but. Okay, that is what is my, for ASIC, right? Initial investment will be very high, but for FPGA, initial investment is very low, but product investment will be high. Product manufacturing investment will be high for in terms of FPGA. Is it clear?
Yes, sir.
Okay. Um, See, cost of ASIC design flow, multi-million dollars, since we need to start from the scratch. ASIC means for from the scratch we have to start. From VLSI design flow from the scratch we have to start. Okay, so which takes lot of money to set up the team. Okay, lot of money it takes. I have to pay for all my 100 engineers actually. Okay, so once flow is working, once one flow is set up, now even Google also initially when they wanted to see Google, you know, everyone knows that Google smartphones were not existing until past 4 years only. Like 4 years only, the Google smartphone came from the 4 years only, right? Even when the initially when they started with the plan, right, they would be invested a lot of money for starting up with this VLSI domain in the Google. Okay, once they start up that one, once they start up it, it will be easier. Once the engineers are present, once the first processor is built, second, third, fourth, fifth, it's all previous versions plus some upgrade to it. That's it. Getting my point? But cost of FPGA design flow, initial investment is less for FPGA since hardware is readily available. For FPGA, right, the boards will be readily available. Versions of the boards will be there. It will be readily available. You just have to purchase the board, implement a product on the board, and move forward. Purchase a board, write some VHDL code for the particular board to operate in some specific behavior like half adder or full adder or any complex project. Move to the next project, like that it is. Okay, so initial investment is less. Purchasing, okay, so that is since hardware is readily available, initial investment will be less. Board is already available, you just have to purchase that board, that's it. Okay, it's like laptop. If you want to purchase a laptop, it takes 1 lakh rupees minimum. I mean, so if you want a good quality, good processor and all, 1 lakh. But if you want to build a laptop, it takes some lakhs, some crores actually. It's like that. Okay, so any VLSI chip can be developed in either of ASIC or FPGA. That's what I'm saying. You can do any of the things. You can use ASIC or FPGA. Companies are there where they use FPGA, where they use ASIC. Companies are there. Okay, but decision is based on overall cost. ASIC based flow, $15 per chip. FPGA based flow, $50 per chip. Why this money is less? Because setup is already present in ASIC. Why here it is cost is because implementation engineers will be needed. So which company goes for ASIC based products production? Companies which manufacture products for bulk usages, they go with ASIC. Google, they're they are developing mobile phones in a bulk actually, right? Even Snapdragon company, Qualcomm, I think what Qualcomm Snapdragon, right? So Qualcomm company, Samsung also, they have their own processor, right? Exynos. So mobile phones sell in millions of numbers. So ASIC style of development is preferred. Okay, which companies go for FPGA based production? Companies which manufacture for limited applications. A hardware used in flights sells in thousands only. Basically, the whatever the flight hardware you see, right? They'll be implemented based on FPGA flow itself. The thing what you have to understand is whatever we'll be learning here in the institute for front-end verification, front-end functional verification, you'll be learning regarding ASIC flow. Institute also provides FPGA design and verification also. Okay, where you'll be learning regarding VHDL. If anyone is interested in FPGA, you can contact Manohar on contact admin on the demo sessions and what is the course structure, everything. So ASIC advantages, cheaper. ASIC is what cheaper basically. When production is in a large number, ASIC becomes cheaper. Consumes less die area, hence it's cheaper. Provides flexibility to customize the design features. Power efficient, ASIC can work at higher frequencies compared to FPGA, hence gives better performance. Uh, Frequency here, there see, FPGA boards are called as reprogrammable boards. FPGA boards are called as reprogrammable boards. Okay, nothing is what there is one FPGA board is present which is doing one set of operation for today. Now you want the same board to be doing some other operation. You have to reprogram that particular FPGA board to some other operations actually. Let's say washing machine operation. You can do that for reprogrammable boards. FPGA is an example of reprogrammable board actually. ASIC is not reprogrammable. Once you manufacture, that chip will be only dedicated for specific applications only. You cannot reprogram and you cannot do any other applications out of ASIC chips. Okay. If the see advantages of FPGA over ASIC, if the chip has a bug, FPGA chip, right? If it has a bug means what? What is the meaning of bug? Not mosquito bug. What is mean by bug in the hardware? Error scenarios. Error
Error.
scenarios. Okay. So if the chip has a bug which is detected after manufacturing, FPGA style won't incur any big cost. Why? Because we don't have to implement the entire flow again. Bug can be fixed in the next FPGA board. In FPGA, what happens if there's an error, right? That error cannot be fixed actually. That error will be as it is in that board. The next development of the board, only the error can be fixed. Okay, but in terms of ASIC, right? If there's a bug present, entire flow should be started from the scratch. That is from the design it has to start again. Suppose your FPGA means ASIC flow, right? Chip, let's say laptop. Okay, final testing happens once the chip comes up, right? Once you get the chip, physical chip, final one test will happen actually. In that test, if any bug is present, entire flow will start from the first. Entire flow means what? They'll discard the chip from the start. They will start. That is what, from the design, verification, everything will start from the scratch. Again, they have to again pay money to the engineers for the same project. It's a double cost. They have cost $100 million. Again, $100 million they have to do on that particular chip again. So in ASIC, if there's a bug, we need to do the entire flow again actually. FPGA flow is quick. Since we don't start from scratch, the board is readily available. It's quick actually. But whereas, see, FPGA projects, right, you can implement within 2-3 months maximum. But if you go to ASIC, right, minimum complex SoC project in ASIC, it will take minimum 1 year. 1 year, close to 1 year, you will get a project in SoC. You see this, let's say, iPhone people, Apple people, right? They'll be working on A17. Assume that A17 processor work will be going on from 1.5 year back only. So you ask any of the Apple engineers, VLSI engineers, they'll tell you that. Means they can tell you some of the features which might come. If they're close friends, then only they'll say. If you go at some random people, they won't say. Okay. So in fact, FPGA is used at in fact FPGA is used at one stage of ASIC design flow. Okay, so FPGA prototyping is used to check the ASIC behavior before it is manufactured. FPGA prototyping is what? Implementing ASIC logic on the FPGA board and check the behavior is what is called as FPGA prototyping. Okay, so we can figure out any issues in the design before going to the ASIC bulk production. Okay, I think this, let's skip it. What is the manufacturing calculation and all, we don't need to worry on that. See, VLSI design flow for ASIC versus FPGA. How the design flow is there for ASIC and FPGA. So VLSI front end domain flow is similar for both ASIC and FPGA. The front end is similar. Okay, so in both the cases, user need to understand the design specifications. Okay, means implement the design using Verilog or VHDL. Verilog for ASIC, VHDL for FPGA. The functional verification of design behavior is using SV or UVM only. The design is only written using Verilog or VHDL. In terms of ASIC, it is Verilog. In terms of FPGA, it will be, the design will be written in terms of VHDL, but verification will be the same only, SV and UVM. Okay. So where do ASIC and FPGA differs? Majorly, they differ in VLSI backend flow. The flow starting from physical design to custom layout. Okay, the way we do floor planning, placement, power planning, CTS routing, IR drop analysis, all these steps is what we are going to differ. Now, what is this floor planning, placement, all these things? Uh, in a top level view. See, I'm not the right person to discuss regarding backend. I told you already. If anyone wants to understand the backend flow, you can opt for the PD training and DFT training, which is going to happen today and tomorrow. But in a top level, if I want to tell you what is the floor planning, placement, power planning, CTS routing, airdrops, it's nothing but, see, in the front end, right, we design the hardware. In the back end, right, the hardware will be equivalent to some blocks actually. How to place those blocks in a given die area? There will be some area present, 3 nanometer area, 4 nanometer area, like that. How do you place that? Okay, and what are checks you do? That is called as routing, IR drop analysis, and all you do for that. How the power should be planned, how the placement should be done on the particular die area, what we have, 3 nanometer area, what we have. Okay, all those things comes under backend flow. Okay, so the backend only what differs from ASIC to FPGA. Let's discuss few concepts on ASIC design flow. Okay, so ASIC design flow is similar to house construction flow, where requirement is what kind of house we need. Okay, house architecture will be there. Okay, so where the architect will take input requirements and output is nothing but what? See, basically you will be giving some inputs to the architects actually. I want living room here, bedroom here with attached washroom, like that. You'll be giving some, this should be balcony. All those things inputs will be providing to the architect actually. What will the architect do? Architect will come up with some plan, some construction plan, house plan he will come up with, right? So constructor or masonry is like what? They take these inputs from the architects and they build the house, right? Later there will be plumber, electrician, carpenter, painter coming into picture for doing the interior works and other things. So basically how many people are involved here? Basically plumber, there will be two plumbers. Hardly there will be what, 20 to 30 people for constructing a house actually, right? So when it comes to the VLSI ASIC flow, right, what happens is ASIC design flow consists of 15 steps divided into two major aspects. ASIC flow has 15 steps. Two aspects are there. What are the two major aspects? Front end is the one aspect, back end is the second aspect. In the front end, what we do? Design requirements. Generally, marketing team does it. Design requirement is nothing but a marketing team who does it. Architects will be there. Okay, architecture basically. Next is RTL design, RTL integration, RTL functional verification. This is where we come. DFT at Verilog RTL level. In the backend, what we are having? Synthesis. Okay, what is synthesis? Whatever the RTL we give, right, from the front end, whatever the RTL we give, saying that functionality is proper, it is correct, we give it to the backend team. The synthesis people, they will convert this RTL into gate level gates. RTL is in a like English language. RTL design will be in terms of English language, Verilog. Okay, now that Verilog should be converted into gates, actually gates, flip-flops, right? So how, where does it that where is that done? It is done in terms of synthesis, actually. In synthesis we convert Verilog RTL to gate level. Okay, so DFT at gate level is done. Next is what, DFT is what, they will basically you do some you generate some test patterns. In DFT you apply some specific test patterns to the design to check it is working correct or not. So that is done in the RTL level also, it is done in the DFT, it is done in the gate level also. Next we come to physical design. Static timing analysis, custom layout, physical verification, GDSSI extraction, fabrication, post silicon validation, and packaging. Okay, so today we have discussed on these aspects only. What is integration, what is design, what is architect, what is design requirement, what is function verification is what we have discussed. Okay, so front end domain flow. So VLSI front end domain is similar to software flow. Software engineer side, what is skill set required for a software engineer? He has to be knowing C, C++, Java. If a software engineer, if a student has to get a job in software engineer, he has to be knowing these three major things, actually, because these three becomes a base for any other languages. So they should be good at reading software specifications, developing algorithms, and implementing the same using C, C++, Java, or similar languages. Should have a good programming skills. So functional verification engineers, you should be having, uh, first thing I'll say is you should be having interest to do programming. Interest should be there. Then only you can become a good programming. Okay, then only you can have a good programming skill. Okay, so VLSI front end domain flow, how it is for us, Verilog, system Verilog, UVM becomes the basic, actually. Okay, so should be good with programming or have inclination towards programming, reading hardware design specification and understanding the design functionality. Basically once you complete your entire 6 months of functional verification course, you should be able to have a good knowledge on Verilog, system Verilog, UVM. Plus you should be having a good knowledge to read the design spec, actually. This reading the design spec is what we will teach you when we go to the AXI protocol and when we go to Ethernet MAC protocol. Ethernet MAC, I told you the projects. Here I have listed on some projects, right? Um, these projects, actually you should be very much good in this. Okay, so implementing requirements using various protocols, you like various USB, PCI, DDR, AMBA, SPI, UART, I2C, I3C, like that. Okay, now question comes, sir, you in the institute you are learning only a handful of protocols, like 3 to 4 protocols only. Where do I learn other things? Once you get into a job, you can come back to VLSI Guru itself, because many of the people they do that. Okay, because you are already learning things from VLSI Guru, you will be getting you will be comfortable with the flow of the institute, actually. So you can come back to the VLSI Guru for any of the other protocols what you want to learn in your industry, in your job, which is required. Okay, so basically they say that people are having 5 years experience, 10 years experience, 20 years experience in functional verification, right? Experience is nothing but what, knowing lot of protocols. They'll be learning lot of protocols, and they'll be getting real time exposure to that particular projects, actually. Okay, you're learning things real time, you're applying it. That only happens in terms of VLSI only. You're learning a thing, applying that thing in real time project, using that in a real time world. It only happens in terms of VLSI. Okay, so what are the job requirements we are having? Again, front end, right? The design requirements, they're called as marketing team, as I told you. Architecture, they're called as chip architect. RTL coding, they're called as RTL design engineers. RTL integration are called as RTL integration engineers. uh, RTL functional verification is called as functional verification engineers. DFT or RTL level is called as DFT engineers. Okay, so our front end course, what we are discussing, right? We are having all of this in our VLSI Guru Institute. Okay, coming to backend synthesis engineer, formal LEC, logical equivalent check. LEC is called as logical equivalent check, which is done once the once synthesis is done. Like, once we get the gate level, right, we have to check that gate level in through LEC checks actually. Logical equivalent check. They're done by formal verification engineers. DFT at gate level done by DFT engineers. Physical design engineer, STA engineers, custom layout engineers, physical verification, verification engineers, GDSSI extraction fabrication team does it. Post silicon validation is done by PSV engineers. Basically, when you look for LinkedIn job openings, right, you'll be seeing these names actually. Okay, that respective course, if you want to use, these are the respective courses which you have to be familiar with, or theoretical concepts. So I think let's ASIC team distribution, mobile SoC project. If you take, right, team size of 50, let's say for example. So front end domain 25 to 30 will be there. Back end domain 20 to 25 will be there. Okay. So where architects, only one architect will be there. Design team will be of 5 to 6. Functional verification engineer will be of 15 to 20. 30 to 40% of the team will be assigned to the functional verification. Okay, so you can also see lot of job openings present for functional verification also. Front end, I'm saying. Okay, so in terms of backend domain, 20 to 25% will be there. Physical design is where the major of the teams will be placed. DFT 2 to 5 people, STA will be 3 to 5, layout will be 3 to 5. Okay. Design overview, DFT overview. Again, DFT overview. What is DFT? Okay, just a top level overview only I can provide you. Okay, so chip can have, see the chip, right, once it is designed, it can have some faults actually. Stuck at 0, stuck at 1 are the major faults what is present in terms of chip. Okay, that is where a signal is stuck at a particular point of 1. Okay, that tracing, that debugging that stuck at 0, stuck at 1 is what is the responsibility of this DFT people. So what do they do actually? What do they do? How do they grasp these errors? What they do is they develop test patterns. ATPG, some test patterns they develop. Okay, so they develop test patterns which helps detect the manufacturing defects in the chips. So example, if a sample pattern, such pattern they'll generate. Okay, so this pattern is applied to the chip. Chip output tells whether this pattern is good or faulty. Okay, so DFT engineers uses various techniques to generate above test patterns. The techniques are scan insertions, ATPG test pattern, BIST test patterns, JTAG, boundary scan, compression. These are the some different logics what the DFT engineers will use to detect the faults present in the design. Once design, after designing, after RTL designing and RTL functional verification. Okay, majorly to catch this fault, stuck at 0, stuck at 1, where a signal is stuck at a particular level 0, it's not changing it, they're called as stuck at 0. Okay, so DFT, these test vectors are provided as input to post silicon validation engineer. So post silicon validation engineer applies these test vectors on the chip using a tester. There'll be one tool, tester tool will be there. So output of the chip indicates if it is working fine, or if there are any manufacturing defects present. If there are defects, then chip is not used for packaging. Obvious, right? If you have defects, we have to resolve those defects. Post-silicon validation engineer takes the text pattern from DFT engineer, applies them on chip and verifies the chip behavior. So percentage of good chips is called as yield. So out of 100 chips, chip manufacturer, 82 chips are working fine, 82% yield we are getting. Okay, suppose you want to manufacture 100 chips. Okay, after the packaging, VLSI front end flow for ASIC ends with a packaging actually. Once packaging is there, the manufacturing will start. If the yield is, if you are out of 100 chips, if 82%, 82 chips are working fine, then it's called as 82% yield what we are getting. Okay, again we have to get maximum number. 82 is not good. So as you guys, most of you were waiting regarding the training schedules. Okay, so what are training schedules present? It's a full week. See, first thing is modes of training, which is offered by the VLSI Guru. So we are having full week mode. We are having weekends only mode. We are having weekdays evening batches. This is not yet implemented. Weekdays evening batches not yet implemented actually because of less enrollments. See, weekend batches, weekdays evening only. Why evening only? Because people are working. If there is a working professional present, so they can't attend the weekdays batches. So what they'll do, they'll attend the evening batches. But this is, since there are not many people present, most of them will opt for weekend only actually. Even coming from job, right, no one will be having that much patience to sit and learn. So many of the working professionals, they choose for weekend only. I would means like who choose for full days? Basically students, right? Like students who are looking for internships or engineer. You are completed with your degree and you are looking for a job. They go for full week training. So full week training, right? We are going to provide three things. One is online, offline, and hybrid. What is mean a full week? Every day session will be connected in the institute. It's up to the student whether you come online. Online means what? Through the meeting, online sessions, through home you will be working, or you can come to the institute and you can take the session, or hybrid, any one of the things you can do. Come here or anywhere. But for every sessions what we do in the full week, we will be giving access to the recording videos for 2 weeks actually. Today's session, if I teach digital, the digital session one will be present for 2 weeks actually. Okay, so some of you, why it is present for 2 weeks? Because first thing is for revision purpose. You shouldn't take that video as a complete training video. No, then there is no point in enrolling for full week. Yes or no? See, if you are completely depending on the videos, there is no point in enrolling for full week actually. So if you are capable to attend every day, I will suggest you to attend every day the online or offline sessions, where you can learn the things through session itself actually. When trainer teaches, there only you can learn. You can ask the questions also there itself. Getting my point? In the trainer you can have interaction with the trainer, you can ask your questions, trainer will solve your doubts, all those things. Okay, so weekend is online session only. Weekend will be completely online. Weekend, Saturday Sunday will be online, because we'll be having dedicated mentors for that. We will not be having the full week trainers for weekend. Okay, so dedicated mentor for offline doubt session also will be there. So for an online student on the weekend, if you at all you want to come to institute for doubt session, right, you can come to institute, there will be trainers present, you can speak with them and clear your doubts for online on weekend sessions. If someone has enrolled for the weekend, you will be having sessions through online only, right? So you will be having you'll be in a mindset that okay, I'm not interacting with the trainer, I'm not getting my doubts cleared, like that. So in that aspect, you can come to the institute will assign a dedicated mentor to you. But before coming, just inform one day back, so that we can have that much time to assign a trainer for you actually. Come to institute, we'll assign a trainer for you, clear your doubts there, clear your questions, 2 hours, 3 hours, how much ever time you want. Then you can be happy, right? So weekend evening batches, this is currently not done. So all modes of training every student assigned with a dedicated mentor for doubt session. Now what is this is something, but you might be a full week, you might be a weekend only. What happens is whenever you enroll, right, you will be put into a dedicated individual group actually. I am not sure how many of you have enrolled, but when you enroll, there will be one group created for you itself actually, where in the group there will be admin. VLSI Guru admin will be there. VLSI Guru founder also will be there in that, Srinivas Reddy. Okay, he basically he sees things, whether things are going fine or not. Okay, next, one mentor also will be there in that. There will be one mentor also added. Okay, next, finance team also will be there. Whatever your finance related queries you are having, you can post in that individual group. Okay, so what I'm saying is there will be one individual group created for you, and on the time of enrollment, any question related to any of your uh, any of your training, right, you can ask in that particular question. Okay, if a trainer is not present, a trainer will be added and he will address that question within one day. He will address, suppose if you post today, within next day evening he will address that question through the message. Or if you want that doubt to be cleared through video, I mean that uh, online, that face-to-face conversion, if you want, that also can be done. Understood my point? This is how that. Any questions here in the modes of training? VLSI RTL design and verification training, design and verification training, ASIC verification training, functional verification training, all are same itself actually. Okay, I think we discussed this in the initial only. Yeah, coming to the timings actually, course duration and the timings. Functional verification training, it's for 8 months. Okay, for weekend, is it, it's a live session. See, you might take a weekend or full week. For both it's a live session only. In the, for the weekend, right, dedicated trainers will be assigned. Means there'll be one weekend trainer only present for that. For weekdays trainer will be there. Getting my point? There are, VLSI Guru has trainers which work for weekends only and weekdays only, like that. Okay. Okay, what is your next question? A weekend timings, right, once after enrollment only it can be confirmed. But generally, I'll tell you, if I take a generic scenario of how it is happening till today, it will be from morning 10 a.m. Morning 10 a.m. to 3 hours session will be there. 3 to 4 hours in the weekend sessions will be there. Okay, for weekdays I will tell you now. I'm coming to that point. So uh, see, others online students, I guess my screen is visible, right? Gayatri and other people, Santosh, Gayatri, Anjum.
Yes, it's visible.
Yeah. Nandini, please log off and log in, because for other online students the screen is visible. I've been sharing it from past 1 hour. Please log off and log in. Okay. There might be some network issues present. Okay. See, functional verification training, it's 8 months training. So 6 days per week. Sunday you won't be having any sessions. For the who are attending for full week, right, Sunday will be off. So Monday to Saturday there will be training. So 4 to 5 hours per day training will be there. Training will start from 9:30 morning. 9:30 a.m. training will start. 9:30 to 1:30 p.m. and possibly after lunch also. Sometimes what happens is trainer might need to take some additional sessions to complete some topic actually. So that time, post lunch also, 1 or 2 sessions, 1 hour or 1.5 hour session we will keep. It's a very rare scenario. That's what I'm saying. But every day you will be having 9:30 to, basically every day you will be having 4 to 5 hours of classes. Okay, that is for sure. Monday to Saturday you will be having. Okay, and every session recordings videos access for two weeks. That video access where it will provided, it will be provided in a InSkill website. I hope everyone are familiar with the InSkill website from the VLSI Guru, right? So although if anyone has not yet got the InSkill credentials, you check with the admin actually. Admin only is the one who can give you that. Check with the admin. But generally, this is a website where each of you will be given dedicated credentials to access your platform, to access your particular videos, your particular course videos. Like front-end means front-end videos, DFT means DFT videos, like that. Printed course materials provided for all modes of training. It might be a full week, might be a weekend. Printed materials will be there, no additional cost. Already everything is means already it is included in your fees only. There is no additional cost for the printed materials and all. It will be given. Okay. For online, right? For the online students who are not able to come to institute and receive the materials, there will be a postal system. Okay, post. We'll be giving you the books through post actually. Okay, once you confirm your registration, those details will be given to you through group. The process will start once the enrollment is done. The process will start actually. Okay, maybe next 1 week you'll be getting that intimation on the materials. Okay, I will tell you. See everything. I'll tell. Yeah, materials. See, if any one of you are attending through the online, right, you maybe some of you might be in a remote area in the sense for out of Bangalore, like you might be in Kerala or Tamil Nadu or Chennai. From there you might be attending the uh, anywhere in India. I'm saying you might be attending your VLSI Guru training. For you people, courier will be sent. The courier procedure means you have to provide your address and all, right? That procedure, the process will start once your enrollment is done. Okay, and give us 1 week to initiate the process. In next upcoming 1 week you will be getting those messages in the groups actually. Okay, regarding the materials. Okay, for the both weekdays as well as the weekend, labs also will be conducted. So labs will be conducted based on theory progress. Theory, suppose let's say Monday and Tuesday, we have completed one topic. Okay, Wednesday, Thursday, you'll be having lab to complete the topic in the lab. Getting my point? Like that, the theory and labs will be going parallelly, side by side. Theory one topic done, lab assignment one assignment should be done. Theory second topic, lab assignment two, like that. Okay. Do you have any questions apart from this regarding functional verification timing? See, for labs, right? No need to come to. What I'm telling is basically, if possible for you to attend the entire 8 months through offline, you can come. There are PGs present near to institute, walkable distance PGs are there. 2 kilometers maximum, not even 2 kilometers, maybe 1 kilometers and below only it is there. Okay, so less than 1 kilometer there are PGs present where it's a walkable distance, 10 minutes walk. Okay, so you can enroll for the particular sessions through online, offline, attend the session through offline. Okay, if you're coming through offline, right, even for the labs also you should be carrying your own laptops only. For the labs you should be carrying your own laptops itself. That is I think for front end you'll be needing laptop, because Verilog, from Verilog, right, we'll be starting with the code, so you should be having your laptops with you. Okay, uh, suppose some of you are not able to attend the offline sessions, you can attend through online sitting in home. For that you should be having your laptop with you. Okay, so online and offline, for both assignment status will be tracked every assignment, every lab sessions. Okay, there will be one Excel sheet which the trainer will be keeping in hand, where they will be keeping your assignment progress. Okay, Any other questions? Okay, so in the 6 days, right? So one question is what you are having is this question. So in the 6 days classes, whether Saturday class for aptitude and communication purposes will be present. See, I'll just give you one small example to understand this. Okay, I'll just show you my. I just wanted to discuss with you how it happens actually, how we are going to connect the aptitude and other things. See, currently, right? Yesterday, today there is one aptitude session present. Okay, if you see SV system of February, April batch, June batch, right? So if you see this batch, you see here there is one message given by the admin in the yesterday actually saying hi all, Saturday we will be conducting aptitude test 4 p.m. like that. This will happen alternative weeks actually. First week, third week, last week.
It will be online or
It will be both. If you want to come
for offline students?
for offline, you can come offline. For online, it will be in online. It will be the same timing only. Same like however we are having the meeting, right? We are having this meeting, right? Same meeting will be there. But what will happen is that test link will be shared in that meeting only. Okay, getting my point. So like this sessions will be there. Online students must attend online and have the basically you should be turning on your cameras to avoid the copy, right? You have to avoid copying and all, right? So that we are making you to turn on your camera actually. Okay, and later must scan and upload your answer sheets and make a PDF of it. Offline students must mandatory attend offline tests only in basically this is the room where you third floor. Currently the session where you are having this room, right? In this room only the test will happen, aptitude test. Okay, this is regarding the aptitude test and all. It will generally happen alternative weeks. Okay, fine. So if I am there in the job job group, right? I don't think so. I'm not there in job group. You can ask for the later you will get to know regarding job group. Similarly, we'll be having one job group actually. Job discussion group, something will be there. VLSI Guru job front end job support group. So in the job support group, you'll be getting uh, all the jobs whatever it comes to VLSI Guru. Okay. So similarly, right, I'll tell you, I'll show you one more thing also. I told you that there will be a dedicated trainer present. So you see, this is some student, okay, Charanya. This student is enrolled for Verilog, Python, and layout actually. Okay, so we see respective trainers will be present here. Okay, so I'm there, which is I'm handling the Verilog, so front end, right? So I'm responsible for Verilog actually. There is Chetan present who is responsible for Python and layout. Okay. Charanya is a student. Bhargavi is the finance team. Quality is the finance team. Manohar is the admin, and Srinivas sir will be there. Like this, for each and every one of you, the group will be created. That's what I'm trying to show you. So in this group, they'll be discussing all the things actually. Institute related, technical, non-technical, they'll be discussing. Okay. Fine. Let's quickly go through it. Go through this. I hope any other questions you're having. Okay. See, course fees, right? Again, it's a finance related thing. I am not the right person to discuss on the finance matters. I am only technical person. Finance related, please contact to admin of VLSI Guru. Okay.
Can you hear me?
Yes, I can hear you now. Yeah.
The lab sessions for weekend batch will be on weekdays.
See, the thing is, in the weekend itself, we'll be having labs. Lab sessions will be conducted for weekend students on the weekend itself. Students on weekend itself. Okay, you can join in the weekend only. Again, how the functional verification training is going to be conducted. Okay, so basically there are three stages. First stage is the P1 stage, where we are taking it as a 3 months course, where we'll be discussing regarding advanced digital design. Okay, digital design plus the advanced. Okay, digital design in the sense what basics, advanced in the sense what interview point of view we'll be discussing. Verilog language, Verilog design projects, and GVIM text editor. Okay, so P2 is a 3 months course. Again, P2 is also a 3 months course where we'll be discussing regarding system Verilog, UVM, Linux commands, soft skills, etc. Placement support will be starting from 5.5 months of training. Okay, and remaining 2 to 2.5 months we'll be discussing on the multiple industry standard projects such as AXI. AHP is not there. Okay, AXI, APB, Ethernet MAC Testbench projects, Python scripting, and SOC flow basics we'll be doing. Okay, so P1 and P2 helps in getting job. Just doing this two, so this two for a fresher point of view, just to, if you dedicate your entire time, concentrate and do properly the assignments, everything right, this thing will get you job in any of the company. It might be product based company or service based company, any of the company. Okay, so these things just add up as an additional for your resume to stand out from the other candidates present in the who are going to apply for the same job. Okay, but if you know these things, if you know this concept in back of your hand, right, you will get job. Okay, we will be evaluating you also. We will also be evaluating you each and every modules to know where you are standing, how to guide you, all those things we will do. Okay, mock interviews, see, it's a request that attend the mock interviews. Even if you don't know anything, attend it. Sometimes, right, when you attend the things, you will know how to answer, how to prepare, where you're standing. That becomes a major aspect actually. Getting my, yeah, see, obviously if you don't answer right, institute will ask you why you're not answering, correct, right? See, if you're not able to answer any question, the the organization responsible for your training will be in a will ask you, right, why you are not answering, why you are, what is the problem. Getting my point? Don't get afraid of those questions. Attend whatever is the matter, attend the mock interviews. Okay, P3 helps you perform in the jobs actually. Okay, so all other institute training stops in P2 itself. Many of the companies, right, what they do is they just do this much of the training and they stop it. Okay, uh, but we will be teaching you some, means they won't stop, they'll basically ask additional fees for doing additional projects. But where VLSI Guru is offering the P3 course where projects are also a part of your enrollment only. Okay, I have a confusion in tools like Model Sim, Costa Sim, Cadence. Okay, fine. Let us see. This is a very important question. I want everyone to. This is a very important, very good question. What is asked? I'll tell you because many of you will be having this question. It's good that one of the student has taken it. See, I have a confusion in the tools like Model Sim, Costa Sim, Cadence, Synapses, VCS, and so on. All these tools are used in the same work or different. See, it all based on the company which you are working on, to be frank. Okay, I'll tell you. See, what are the companies? I list down some companies. Okay, just I list down some companies. Qualcomm, companies Google, where I'm okay. Uh, we are having what? Samsung, Nvidia. Okay, Nvidia. We are having, these are all product based companies. What I listed down. Some service based also are there. SmartSock, Mirafra. Few of the product based companies I'm listing on. Few of the service based also I'm listing on actually. Mirafra, okay, Wipro, then SmartSock Solutions. Then we are having what? Digicom. Then we are having there's one company recently, uh, Sasken, Sasken, okay, Sasken Technologies. So these are the product based companies. These are the service based companies. What do service based companies do? Service based companies, they hire the people for less salary. Okay, less salary means we can expect 1 lakh for experienced people. Minimum 3 experience means 1 lakh. 20 to 20, 25,000, 30,000 for freshers. 30,000 maximum for freshers. No, minimum 30,000 for freshers in terms of service based company. Freshers in terms of product based company will be around 80 to 90,000 per month. I'm saying. Okay. So here, what happens is they hire you, they project you to the any one of these clients. Okay. Now what is common? Qualcomm, let's say Qualcomm has Qualcomm, right? If you are put into Qualcomm project, Qualcomm will be working only on VCS. Generally, VCS Qualcomm takes care. Google is also working on VCS only. Samsung has Exilium. Synopsys is VCS. Cadence is Exilium. Nvidia also is, I think, Exilium only there. I'm not working in Nvidia. Yeah, I think Exilium only is also. I'm not sure. But what is the thing I'm trying to tell you here is you learn Model Sim, you learn Questa Sim, you learn Cadence, you learn Synopsys, you learn VCS. It's not that you should be doing in one project, you have to do everything. No. You'll be working on every tool. No. One project, specific tool you'll be working on. Okay, suppose let's say in the institute you learned Model Sim actually. What is the flow? Generally, what is the flow of execution? It's compilation. We have to compile the code, elaborate the code, add the signals to the waveform, and run the simulation. These are the 4 steps. What is common? These 4 steps are common in all the tools also. Okay, what is differing is nothing but the user interface, GUI, graphical user interface, is what is differing, and the features will differ. Features. VCS will be having some features which are not present for Model Sim, Questa Sim, Cadence, right? So that feature will be, you have to learn that feature actually. How will you learn that feature? You need not to worry. Once you get into a company, right, as a newly employee, you will be given that ramp up time actually. 1 month of the joining, you will not have any work actually. Any company you join for minimum 1 month, you will not have any work. That is for ramp up time, we call them as. Because the candidate should be familiar with the environment of the company, not only with respect to technical, even non-technical also. So the travel, people have to get adjusted with the travel and all, right? They'll give you time. 1 month time will be there. So you can ask your colleagues, right? Ask your colleagues, or companies will be having their own learning platforms also to learn the tools. Getting my point? Don't worry about the tool actually. I'm telling you, as an experience, I'm telling you, don't worry regarding the tool. See, I have worked in multiple companies, I have worked in multiple tools also, but don't worry the tools. Tool you can learn in 10 days, I'll tell you. Okay, minimum 10 days you can learn a tool, but concept you cannot learn in 10 days. You have to take a lot of time. So focus on the concepts. Don't worry on the tools. In the resume, they won't check what tool you have done. They won't check that. It's a lower priority. That's it. Okay. Tools you can learn anywhere. You're getting my point. I hope it is clear here. Santosh.
Yes, sir.
Okay. Um, so for anyone who is joining as a experienced in this particular training, that experience session will be of 6.5 months. Same thing, 4 hours per day will be having 9:30 to 1:30. Recording videos also will be provided for 10 days for every session. Okay. Training is divided into 2 phases for experienced, P1 and P2. Okay. 4 months we'll be discussing on system Verilog, UVM. Okay. 2.5 months we'll be discussing on the projects. Anyone who's joining as experienced training, online, offline, anyone is joining for the experienced training for function verification. Okay, I think no one. So FPGA system design training, again it's a 6 months. FPGA is a 6 months. So where 3 stages. First stage you will be learning regarding digital design and Verilog, and one text editor, GVIM. Okay. Uh, Next you will be learning regarding FPGA flow in depth, where you'll be learning regarding FPGA boards, standard protocols used, Linux commands, soft skills training, and placement support. So P3 will be for implementing multiple projects using FPGA boards. Okay. So there will be dedicated demo sessions for FPGA also. Today is not the demo session for FPGA. I am not doing FPGA demo session, just giving some basic intro. Okay. Anyone is joining with FPGA? Okay. So DFT course, as some of you were asking for DFT course. So it's a 26-week course actually, DFT. Okay. Anyone is joining with DFT? Online, offline? Okay. So recording videos access for 10 days for every session. Training divided into 3 phases. P1, P2, P3. First 8 weeks, 10 weeks. Then I think regarding this, they will discuss again in depth for your DFT demo today evening. Physical design is also 6.5 months course. These are the concepts what you'll be going through it. Okay. So choosing of right course, there are 3 kind of expertise: functional verification, FPGA system design, VLSI backend flow. These are 3 major categories. So what are the requirements is what is. So functional verification requires a good level of programming expertise. How do you get the programming expertise for the functional verification job? You have to be interested in the programming. We are having good job opportunities also. FPGA, medium level of programming expertise plus expertise of working with tools actually. Majorly tools you should be knowing in terms of FPGA. Programming also a little bit you should be knowing. Even FPGA also are having equal job opportunities as of front-end function verification. So VLSI backend, right? Physical design, DFT, STA, and custom layout, they come under VLSI backend domain. What VLSI Guru is offering. In this requirement is no programming language. You do not need to have any programming skills. Okay, some scripting skills you should be knowing that we will teach you. Tools and technology oriented jobs is physical design. So course flexibility, you can join any of the course what you feel you want to join today. Means some of you will be influenced from the friends saying that my friend is joining this course, I also want to join this course. But your interest you might understand once you go through the course only. Correct, right? So what is the flexibility VLSI Guru is offering here is join any course, switch to any other course up to 2 months actually. 2 months time we will give you. In 2 months, suppose today you joined front end verification. You think that okay, I am not able to cope up with the language after providing our support also. If you're not able to provide, you know, you got to know that your interest is in not in programming. Okay, you have a flexibility to join the backend. They we won't cost any additional, no cost is there. Okay, whatever the fees you have paid for the initial joining, the same fee will be compensated for the your course change also. So no need to repeat entire 2 months in the new course. Initial 1 month is common for all the courses. You join the next batch of the training where 1 month topic are covered. Okay. So preparation for the jobs. What VLSI Guru provides for the job preparation. Uh, Difficult part of the training at VLSI Guru is things move quickly actually. See, we will be going on with the concepts. Okay, see, we can't wait for 1 year for one topic to complete, a course to complete. We are also having some deadlines actually. So 8 months is what we have planned for front end function verification to complete. So for the 8 month plan duration, what we have the schedule, that schedule will be following. It is your responsibility is to complete the things as soon as possible. It's not that we go fast, we go in a medium pace. Okay, but you have to cope up with the things. You will feel 8 months will go like this actually. To be frank, 8 months will go within a flick, it will go. Okay, so you have to every day concentrate and do the things, assignments, attend the labs, attend mock interviews, everything. From your side you give 100%. We are giving you 100%. From your side you have to give 100%. So 3 weeks are fully dedicated for digital design. I think this already I've told you. Digital design, Verilog and all. I won't go much in detail. But a good 6 hours effort per day, including the sessions time, is sufficient to get a job. Means you have to minimum spend 6 to 8 hours. What I will say is 8 hours you spend per day. Morning 4 hours, take lunch break or some 2 hours break. Afternoon 4 hours you study. Sufficient. Morning for 4 hours is institute. Evening 4 hours you study from your end. Okay. See, Sunday is a week off for you guys. Means no institute is there. But for you, you have to prepare from your end. Don't take holiday. Don't say that I will not learn. You study something, revise the concepts. That is what is needed actually. Okay. Okay, fine. Let's. See here, 8 months is what we are committed for. The front end function verification is 8 months is what we are committing for you. Okay, uh, but I told you right, it's not that after 8 months you will get job. It's not like that. I told you initially on, right, you have, if you know system Verilog UVM, you can apply for job actually. You can apply for job, mock interviews you can apply. We'll be also sending you the job requirements, and you can apply for the job within 4 5 months only. After 5 months of training of function verification, you are ready to put the job. Okay, but course completion is what the project point of view, that we will it will take 8 months. But 5 months is what is needed for us to train you to get into a job actually. Okay, remaining 3 months is for projects. Is it clear? See, if anyone is having IT experience, there's a question that, sir, is there IT experience will help in this domain? Like previously, I worked 1+ years as front end developer. See, IT is a software actually. IT is a software. Uh, there are things. What happens is, if you are very much good in your entire course, right? Whatever the course we are going to teach you, front end verification, you are very much good evaluation and you are able to score extraordinary. All the mock interviews you were able to ace it. Okay, so what you can do is, you can project that 1 year of experience what you had in IT as a 1 year of experience in the VLSI. You can project it actually. Again, there are some procedures present for that. Maybe this question you can ask to the institute once you are going to apply for a job actually. Santosh, you're getting my point. But what I'm saying is it is possible. The way how to do it, you can ask the institute after once you start applying for a job. They'll tell you the required things to be done. But it is possible if you know things, whatever the 8 months of course we are doing, we're able to know the things very well. We're able to perform very good. You can put 1 year, means if you have a experience only, like he has a 1 year of experience before, so you can show that 1 year of experience as the same company as VLSI. Okay. So performance gap, good, average, poor, this is how we track. Okay, so performance tracking parameters are what? Assignments, we keep track of each and every individual students. So 10% of attendance, 20% of evaluation test, 10% of percentage presentations. I told you, right, we'll be having presentation sessions. So students in is given a topic, asked to do the presentation, one presentation every month. One student has to do one presentation every month actually. We'll assign you the topics. This is mainly meant for improving your speaking skills. Okay. So dedicated WhatsApp group for every student, trainer, admin. I told you already. I showed you the real time how it is being done. Okay. So final goal of 8 months training is what? Students should be enabled to work in a job independently. Okay. So it is collective effort. It's not only institute or trainer. It is students also should provide the same effort only. Both provide the same effort, then only you can be good. See here, the course duration for the weekend, right? It will obviously vary actually. People who are attending for the weekend, it will vary. It might go for additional 3 months extra. Okay, 11 to 12 months it might go for weekend students, because weekend means what? Only 2 days only you are attending in a week. Yes or no? Weekend means only 2 days you are attending in a week. So 8 months is not the completion session. You will be taking additional 3 to 4 months extra, I will say, to complete the things in the weekend batch. Okay. So sir, presentation for online students is no, I didn't understand. What is this? Okay, the presentation. Okay, the presentations you can provide in the online or offline, however you want. You can provide. For online students it will be online, for offline students it will be offline. That's it basically. Okay. And one more thing, whatever the presentation we show during the course, right, Verilog, we show one presentation using a presentation PPT only. We explain you the topics. That PPT will give you the hard coded also book. Okay. And that presentation will also be available in your InSkill website also. Course prerequisite. See, I telling you, you don't need to have any technical prerequisites. Okay. Only thing is what? Students should have ability to understand the things. That's it. Understand what we are teaching, understand the problem. Okay. Should be able to do logical analysis. Suppose at the end you should be able to have some knowledge of logical analysis here. Take a sample test. If a score is less than 40%, I think this is something which we are not doing as of now. But what I'm telling is, what is the course requisite for function verification? You have to be having an interest to learn the programming actually. Interest should be there. We will teach you everything. Okay, we will teach you things from the basic. Okay. Some of the testimonials they have just given here. Okay, I don't, let's not spend time. because you can see this even in the reviews of the VLSI Guru Institute also. But what I'm saying is, see, people have got jobs actually. Okay, we for personal reasons we are not going to show the names and all, but what you're able to see here, basically after I joined Bitsilica, then I realized that content, syllabus and teaching of VLSI Guru, which is far better than other institutes. Okay, so as well as the teaching and use cases are very practical and at the industry standards. See, these are not, these are all the uh, testimonials, what the feedback we are getting actually once the 8 months session is completed. Okay, the only request from my side is, do not divert yourself, please focus on the concepts. Okay, so I won't see, it's already been time, I won't go much on the testimonials. The thing is, we are having as an institute, right, we'll provide our best for you. It is up to you that you have to give the same effort back to us so that you will be in a beneficial way. Okay, see, if you want to do any work, right, the effort should be from both the sides. One side effort will always lead to nowhere, both the side effort should be there. Okay, so training flow, design verification, Verilog, system Verilog, UVM and expertise you will be getting in all months of 8 months duration. Okay, initially you might feel that you don't know what is VLSI, but at the end you will be having what you are doing, in the job you will get that overall complete picture. Okay, I will stop the session for here. Okay, so I have spoken a lot, to be frank. What you're saying, yes, sir. No, I understand. To session was 30 minutes more it has gone. But anyhow, but I hope we have discussed all the important topics, what is required for you to get a top level overview on what VLSI Guru is offering in functional verification flow, and what is required from the students. Okay, what is if you have how the students questions have been answered, how the student can address his or her question in the WhatsApp groups, where you have to address all those things. Okay, so if you have any additional questions, I will take it here. Okay, any additional questions are there on the VLSI Guru Institute? I can uh, address it. Do you have any additional questions? Not a problem. If you are having 1 year career gap also, not a problem. In the interview, you can say, we see, in a personal experience, I will tell you, I'll tell you, I'm telling you with respect to the industry actually. See, I'm working in an industry, so I have interviewed a lot of people who are having 10 years career gap also. The thing is, they would have worked in a company because of family. What happens is, they would have taken a long gap, maybe they would have gone to foreign or something like that, they would have taken long gap actually. What they're doing, they're reskilling themselves, like by joining institutes or etc, again going for the industry. That is how they do it actually. Okay, you can do it. See, 1 year is nothing, to be frank. 1 year gap is earlier in which company you were working on? Huh? See, not a problem. Don't worry, not a problem. Okay, you still having time. You can still enroll for the course, complete the 8 months of training. Within 5 months, you can apply for the job also. Okay. I'll tell you as what I have seen. Like, I have seen people who are coming into the industry having 10 years of gap also. 2 years, 3 years, because of some issues, or they'll be, basically what happens is, some of them, they'll go to the IAS and all, right, right, the trainings they do. 2 3 years they spend there, then they come back to the industry. Okay, that they do it is in that point of view, don't worry. The skills, if you have, industry is ready to hire you, that's it. Okay. Regarding next class is your digital session. Okay. Regarding that, we will we will keep you updated in the group when it will start. Okay. So right now, how is the market? Are they hiring? How many students are getting last 1 year actually? See here, basically, right? I'll tell you. Uh, last year, right? Some of my students actually. See, I was doing UVM system log and all. So some of my students they have got job in the past 1 year. Like once they complete UVM projects, they have got the jobs. Okay. See, hiring in the company it varies every month based on the projects what they get. It is today I'm saying one number. It might not be the same after 8 months actually. It's not predictable. See, whatever the number I give it today, it's not predictable there. You do best from your end. See, I'll tell you one thing. 100% placement is there. No, what the institute will say. It is not the institute hand actually. To be frank, institute has no control over the 100% placement. Okay, when you say 100% placement, no. See, suppose a student is there who is not at all performing. We will should be able to provide them the job. You think logically actually. Think your point of view. A student is enrolled, he has not done anything, he's asking for job. How can the institute provide? Not possible, right? If you are giving your best, institute also is provide your best. You can get your job from your end only actually, to be frank. Institute also will provide job. It's not like institute will not give any job openings, they will give. But you can go out of the institute and also you can give your own effort. That's what I'm saying actually. Okay, but institute, there will be some companies tied up to the institutes actually. If those companies has a opening, then only they come. If they don't have opening, why will the company hire you simply, and why will they simply pay you money? Tell me. Think you are a company owner. Okay, you don't you itself are having problem in the money flow. Why will you hire new candidates for jobs? Thinking, you have to think that point of view, think in a higher level view actually. Getting my point? Think yourself. So when there's a opening, right? VLSI Guru is tied up with a lot of companies. I'll say Wipro is there, Salscan is there, Digicom is there, SmartSock is there, Mirafra is there, right? There are people who have also got jobs in terms of Samsung, Nvidia, and all. Okay, so you give your best. Okay, after 5 months, when you apply for a job, if you're not given a call, then you can ask institute again. Getting my point? But what is happening is, I'll tell you from I have seen myself. What is happening is, when the job openings comes, none of you will apply for the job, thinking that I'm not prepared, I'm not prepared, I'm not prepared. Obviously, if you would have focused on the day one, you would have been prepared. If you are waking up at the end of the session, you are not prepared. Correct, right? That is what happens actually. See, I was also a student. I'm telling you in the student point of view. I'm not like 10 years, 20 years experience and all. I'm just 5 years experience only. I was also a student. I know how a student will think. I'm also your generation only, to be frank. Do you agree? I am also your generation only. We were using phones when we got 10th only, we got phones in our hand. Correct, right? Even you are also the same generation only, right? Yes or no? Same thing only I'm
Inter.
saying. See, 5 years, with what I'm saying is, focus on the training. Worry about the job after 5 months. Once UM is completed, that time you think about the job. Now you should be on study point of view only. Understood? If you are good, we will only recommend you for a company. I am doing UVM sessions, system evaluation I handle. I recommend some when they ask me, right? See, this happens for every trainers. The admin will ask the trainer like, is there any good candidate where we can project them immediately for the jobs? I have recommended many people, saying that these people are good in the basics knowledge. You can ask them to, you can send the resumes. So when mock interview will be conducted, we'll tell you where you have to answer, how you have to answer, then you can go and give the interview. Getting my point? This is done. You ask for any trainers in VLSI Guru, we do this actually. Okay, or if you have any of your friends who are already passed out from VLSI Guru, you can ask them also. Okay, understood my point. Okay, fine. So any other questions? Okay, what is your question? I didn't get your question then. Sir, I have questions. No, no, I have question. There is a less than 60% in my 10th. So will it see? I'll tell you. Percentage is there, right? It is just a number. I'll tell you. Percentage is just a number. I'll tell you openly. Please don't disclose to anywhere. I have a aggregate of 61% only. Okay, I am working in a product based company. Okay, I am having some handful. I am living a very good life. Okay, so now tell me, percentage matters. I am a living proof. Actually, you can take me as a living proof. I am having 61% on. I'll tell you openly. I am not ashamed of this. I am actually a VTU. I think now also it's there. I guess so. VTU student. I am. You know how VTU examination conducts. I hope some of you who are VTU, you know what it is actually. Whatever you write, they will not give marks. That is how it is actually. For me, it was that experience only actually. Okay, don't worry on this. See, don't. This is just a number actually. What number they'll take? It is a number because suppose there are 100 people present. Now, a company can't have 100 positions, right? Company has only 2 or 3 positions on the left. This is a criteria for filtration. But when you join a institute, we are only if you're even if you're 60%, if you're performing like 100% candidate, why don't we recommend you actually? We will say that he is a very good student. We will ask him to. We will tell that he's a very good person. He knows very concepts technically. He has a very good skill. You can take him. Like that, we'll say we'll arrange an interview for you. Don't worry on this. Don't worry on the number. You have joined an institute, any institute. I'm saying, don't worry on the number. I'm telling this with respect to the job what they're seeing. The number is just for your campus placements and all. Number is there for if you're going outside the job, your skill is what matters. Okay, getting my point. So I was good in. I had an interest. See, from the childhood, right? I had an interest on how the things work actually, how a system works. I used to have that curiosity. So I was driven by my curiosity and I joined VLSI. So now I'm happy that whatever I'm working on, the same thing I'm using in my real life, and I'm happy for that actually. That happiness, if you are getting, you are good in life. You can get settled. See, your driving should be what? Not job. Driving should be if you are happy in the driving should be what you're interested in. That should be your driving concept here. Understood my point? And don't go and say this number to anyone else. Okay, it is something which I don't know why I told this. It's something which I told for only this batch, because this is the first question when this is a question only in this batch I got like this. Okay, so do not say my number to anyone. Getting my point? Okay, let's keep it as a something between us only. Okay, so let's complete this particular training demo session. I hope you were able to get enough knowledge on what is expected for the next 8 months. So I hope all the best for you guys, and I hope I'll meet you guys somewhere in the 8 months of your training. Okay, let's see what happens. Okay, thank you everyone. All the best. Okay, sure. Thank you.